Hi everyone, good morning. Welcome to Vedanta NEET English. I am Diksha Kaushal, your chemistry master teacher. And students, today we are going to do biomolecules, and we have completed almost all the chapters of organic chemistry we have completed. Be it haloalkenes, haloarenes, aldehyde ketones, carboxylic acid, alcohol, phenols, ethers, and amines also, right? So are you excited that we are almost completing the syllabus? Maybe today we will complete all the chapters except for one chapter, that is P block, right? And so many of you wanted P block from NCERT line by line. So I'm going to take up P block from NCERT line by line from the next week. So this week is going to be the end of the chemistry, but only the theory part. After that, we will start with the practice sessions, right? Okay, very good morning, everybody. Very good morning. So, yes, green hearts in the chat box. Everybody, firstly tell me if I am visible and audible clearly to you. And shall I start the lecture or not? Yes, fill this chat box with green hearts so that we can pump up the energy and we can start the session. Okay, it's a very easy chapter, and you have also seen this chapter in Biomolecules, I think class 11th, Bio, right? Right. So, it is not something that you will feel like, ma'am, this is pure chemistry. Yes, we will talk about structure here, but it is somewhat related to bio as well, right? So, those students who are scared of chemistry and are lover of bio, I think this is going to be their favorite chapter, right? Because it is related to bio, isn't it? Yes. Very excited. Okay, Soumya, Wilson, Kani, Madai, Evening Star. Yes. Okay. Let us start this session without wasting any time. Now, biomolecules. Biomolecules means we are going to talk about the natural products, right? So basically, in your diet, okay, whenever you are eating something, what you're eating, right? What you're eating? You're eating carbohydrates, you're eating fats, you're eating proteins, right? So in this chapter, we are going to talk about carbohydrates like glucose, sucrose, fructose, different forms of sugars, right? Then we are going to talk about how in our body there are different carbohydrates present, there are different structures present, right? Molecules present naturally in our body, right? Then we will talk about vitamins, right, which are also very essential for our body, right? We will talk about proteins here, we will talk about structures of protein, and most important thing, we will talk about DNA and RNA, right? And from these predictable questions are asked. So let us start the session. Okay, ji. Now, starting with the first thing, as I told you, when we eat something, right? So they always say that when you eat something, eat it in proportion, right? You can't eat so much of rice with little bit of dal, right? You need to have a proper proportion. Why? Because our body needs an sufficient amount of carbohydrates, but it also needs proteins, it also needs fats, right? Okay, you can't just eat roti and you're like, I don't want to eat any sabzi, right? What will happen? Your body will be filled with carbohydrates. That is why in your body your protein level is going to decrease, right? So all of these things are basically related to your daily life only. Now if you talk about the carbohydrates in bread, in rice, in chapatis, we have carbohydrates, right? Carbohydrates are present there. So now carbohydrate simply means that sugar, right? Sugar means you will say, ma'am, okay, sugar is present in chapati, it is present in rice. Yes, a different kind of sugar, right? A different kind of sugar is present. Carbohydrates may be defined as optically active polyhydroxy. Polyhydroxy means more than one OH group is present. Aldehydes means it will have aldehyde CHO group or ketonic group, that is C double bond O group, or the compounds which produce such units on hydrolysis, right? So basically they are saying that if you talk about carbohydrates, we will talk about glucose, we will talk about fructose, right? Then combining, we will talk about galactose, right? Combining these units, you will form disaccharides. I'll tell you what is disaccharides. Combining these units, you will form sucrose. maltose, lactose, right? So these are all things they are saying that units on hydrolysis. For example, sucrose on hydrolysis, it will give you glucose and fructose, right? So basically they are saying either it can be directly, which is having polyhydroxyaldehyde or ketones, or it is giving polyhydroxyaldehyde or ketones after the hydrolysis, right? Okay. Next is some of the carbohydrates which are sweet in taste, yes, are also called sugar, right? They are also called sugar. Most common sugar used in homes is called sucrose, where the sugar present in the milk is known as lactose, right? Galactose is also present in the milk. Lactose is present in the milk. Galactose is present in the milk. That's why when we say, okay, this person is lactose intolerant, right? That means they are not able to digest that particular thing, that particular compound. They are not able to digest, right? You must have seen Priyanka Chopra's interview saying that she is lactose intolerant, right? So basically, these people can't drink milk, right? Or any lactose compound, right? Any lactose thing, that is, if you talk about curd, milk, or even cheese, right? Okay. To some it is digested, to some it is not digested, right? Carbohydrates are also saccharides. Now let us talk about what is saccharides and what is disaccharides, right? Now let us see the classification based on the saccharides. So saccharides is a term used for carbohydrates, right? If it is monosaccharides, that means on hydrolysis it is not further giving any other carbohydrate, right? Cannot be hydrolyzed further to give simpler unit of polyhydroxyaldehyde or ketone. But disaccharide is when on hydrolysis it is giving a monosaccharide, right? Carbohydrates that yield 2 or 10 monosaccharides on hydrolysis. What is polysaccharides? If you talk about, this is basically oligosaccharides. If you talk about disaccharides, oligosaccharides is a type of disaccharides only. Okay, di, tri, tetra, penta, hexa, right? All these are under the oligosaccharides. In oligosaccharides, if it is giving monosaccharides from up to 2 to 10, then it is called oligo. If more than 10 units it is giving, then it is called polysaccharides, right? If a large number of monosaccharides is given, that is called polysaccharides. Okay, so that is the classification. Let us see in detail. Firstly, though, we will talk about monosaccharides, right? Monosaccharides, we will talk about glucose, we will talk about fructose mainly, then we will talk about galactose. These are the 3 monosaccharides that we are going to talk about, right? Glucose, fructose and galactose. What are the 3 monosaccharides? Everybody in the chat box. 3 main important monosaccharides: glucose, fructose, galactose, right? When we know the structure of these 3 things, firstly, though, you need to understand 2 main structures. One is glucose, other is fructose, right? If you understood these 2 main structures, then after that things will be really simple for you, right? You don't have to remember that other thing, right? Okay. Yes. Now let us see, monosaccharides are further classified based on the number of carbon atoms and functional group present. So now if you talk about it, if it contains aldehyde group, that is called aldose. And glucose is a type of glucose or galactose. They are, this is the example, okay? This is the example. This is the example. Which has aldehyde group, that is called aldose, which contains ketonic group, that is called ketose. Now, ketose is, example is fructose, right? The example of ketose is fructose, right? Here you can also write galactose. They both will contain aldehyde group and this will contain ketonic group, right? Now, let us see based on the number of carbon atoms as well. If the carbon atom is 3, then the general term will be based on the carbon atom, that will be triose, right? If it is from 4, that is tetraose. 5, it is pentose. If it is 6, that is hexose. If it is 7, it is heptose, right? That is only tri, tetra, penta, hexa, hepta, right? Octa, all of these things we have written. Now, if it contains aldehyde group, we will add ald here. So it will be aldotriose, aldotetrose, aldopentose, aldohexose, aldoheptose. If you have keto group, ketotriose, ketotetrose, ketopentose, ketohexose, ketoheptose, right? Simple. 1, 2, 3, 4, 5, 6, 7, 8, right? That is tri, tetra, penta, hexa, hepta, octa, right? This you can write. If you want to talk about aldo and keto, just write in the prefix aldo or keto, right? Okay. Now, next is preparation of glucose. How glucose is prepared, right? How glucose is prepared? Basically, glucose first it will be prepared from sucrose, right? Sucrose structure also we will discuss. This reaction again we are going to discuss further, right? Now we are saying that sucrose, which is a disaccharide, okay? Which is a disaccharide. It is a disaccharide. Now this disaccharide on hydrolysis, it is going to give us two things. One is glucose, other is fructose, right? This is how glucose is formed here. And this is a very, very important reaction. We will talk about this in detail when we will talk about sucrose and the properties of sucrose, right? If sucrose is boiled with dilute HCl H2SO4 in alcoholic solution, glucose and fructose are obtained in equal amounts, right? In equal amounts they are obtained. Next is from starch. Starch is again a polysaccharide unit, right? It is a polysaccharide unit. It is not a disaccharide. It has a tons of units that are attached together, or glucose is attached together to form a starch. Right? Now, when you hydrolyze the starch, now because I am telling you this is a polysaccharide, right? When you hydrolyze this, you will get so many units of glucose because it is found from glucose only. This we will talk about when we will study about starch and cellulose, right? Okay, now you just have to remember this is a disaccharide, that is why it is giving only 2 units. One is glucose, one is fructose. It is a polysaccharide, right? It is a polysaccharide. It is a polysaccharide, that is why it is giving n number of glucose units, right? Okay, yes everybody. Now, let us see the structure. Now, from these structures, questions can be asked, right? From this, we will talk about that who told that this particular thing is the structure of glucose, right? Okay, in your syllabus in detail, you have the structure of glucose. Now, here we are talking about alpha glucose, not beta glucose. We are only talking about alpha glucose. Now see one thing here. One by one we will talk about the reactions, right? So the first reaction that is going to first, so they are just telling you that this is the structure. Glucose is a aldohexose, right? We will also talk about why, like what are the reactions that told us that it is a aldohexose, right? It has 6 carbons, it has aldehyde group, it has alcoholic group. How many alcoholic group it will have, how many it will be primary, how many it will be secondary. We will talk about all of that in detail, right? So basically now you need to remember that this glucose is a aldohexose. That means it has 6 carbons and it has a aldehyde group, right? Now, and is known as dextrose. It is also known as dextrose. Right? Why it is known as dextrose? Why it is known as dextrose? Because it is showing this positive. That means it is shifting the plane polarized light. I told you this in optical isomerism that this is your compound. When the plane polarized light is passed through it, if it is rotating it on the right side, right? This is your plane polarized light. This is your plane polarized light. This is the compound. You're passing it through it. Now, if it is rotated to right side, then we will say that it is a dextrorotatory because glucose is dextrorotatory. That is why it is called a dextrose, right? Next is, it is monomer of many of the larger carbohydrates, namely starch, right? As I told you, so many, like n number of glucose compounds, they will combine together, glucose units will combine together and they will form starch, right? That is why starch is a polysaccharide, right? It is probably the most abundant organic compound on earth. Now, as you can see here, this is the structure of glucose. right? This is the structure of glucose. We will talk about all the things here, right? This is the aldehyde. These are the 4 and 5. 5 which groups? 5 apna OH groups. That is why it is pentose, right? That is why not pentose. Yeah, it has 5. No, it is basically hexose only. Yes, but it has 5 OH groups, right? Some of them are primary, some of them are secondary, right? Now, let us see one by one how you can construct the structure, right, of glucose. So, first thing is we want to know about the molecular formula. The molecular formula was C6H12O6. Now, ma'am, how can we write this molecular formula? Who told us this molecular formula? Molecular formula are studied on the basis of NMR spectroscopies that are not in your syllabus, right? That is in the higher classes, right? So basically this is through graphs you study a particular structure and then you combine that what exactly, how many oxygen it has, how many hydrogen it has. Even NMR spectroscopy also tells the nature of that compound, right? Whether it is having aldehydic or ketonic group, right? Okay, from NMR spectroscopy also we can identify that, right? But now let us talk about this thing. Now you know the structure of, you know the molecular formula of glucose. Next thing is to know how many, like all these carbon atoms, they are connected to which thing? They are connected to a normal chain, they are connected in a branching. What kind of thing is it? Right? So we will react glucose with HI at a prolonged heating. What will happen? We will get N-hexane. Right? That is a simple carbon chain is formed. A simple carbon chain is formed. So when you have a simple carbon chain, you can directly say that there is no branching here. Right? HI means you are doing the reduction here. Right? HI is a very good reducing agent. Right? You are doing the reduction here. You can write here, you are doing the reduction. Now students, in the next 10 minutes, we will revise all the reactions that we have done, mostly the reactions of alcohols and the reactions of aldehyde and ketones we are going to repeat here. Right? This I have told you when we were doing hydrocarbons as well, that HI is that reducing agent which can reduce OH group also, which can reduce aldehydic group also, which can reduce like even COH also. Here we don't have carboxylic acid, but it can reduce most of the groups, right? So that is why here after reduction we have normal chain, that is we can say that this glucose is linked in a normal chain. There is no branching in the structure of glucose, right? The third thing was to identify whether it has aldehydic group or it not aldehydic. Firstly, we need to know whether it has COH group, it has aldehydic group, it has ketonic group, it has amide group, it has acid chloride group, anything can be there, no? So we want to understand what kind of group it has, right? So we will have two reactions here, and these two reactions are the reactions of aldehyde and ketones. So first students, we know that aldehyde or ketones, they have this carbonyl group. When they are reacted with NH2 and this is Z, then what kind of compound, what kind of product they will form, right? Water will be eliminated from here, and you will have the formation of C, this is double bond, and nitrogen is connected here, and this is Z. Do you remember this? Array, I am live only. Right? So guys, do you remember this thing? Now H2 and oxygen, right? This will be eliminated as water from here, right? Now this is the reaction of aldehyde and ketone, right? Now I'll just replace this Z by OH. You can do any other reaction. Here, right? So here what we observe that this kind of thing is getting formed. Right? That means this kind of thing is getting formed. That means oxime. This is the structure of oxime, no? This is structure of oxime. This also I have told you in aldehyde and ketones. Right? When you have NH2OH, then you will have the formation of this double bond N single bond OH, that is called oxime. Right? This group is called oxime. Right? So oxime is formed. Here we can say that aldehyde and ketones are present here, right? Either aldehyde or ketone is present here. Now you're like, ma'am, I want to do one more reaction. I am not sure, ma'am, whether we are right or not. Okay, do one more reaction. Now, this is HCN. Now tell me, students, how HCN will behave with the carbonyl compound. Right? You have a carbonyl compound. You have a carbonyl compound. Right? This also we have done. Right? This is H positive, Cn negative. Right? I told you that in carbonyl compound, what are the reactions? What kind of reaction it will show? Right? This pi electron are going to shift here because oxygen is more electronegative, and here it will be positive, it will be partially negative. That is why this is going to attack here, and hence you will have the formation of this C, these bonds here. Then this is O, and this is Cn, and this is O negative, and to this H positive will be attached, and hence you will have this thing. Right? Cyanohydrin is formed here. Right? So once if on reaction with HCN you have the formation of cyanohydrin, that is CHCN here and OH here. This is the same thing that we are forming here. OH and CN. This thing is called cyanohydrin. This is called oxime. This thing is called oxime. This is called cyanohydrin. Cyanohydrin. So can we say that yes, ma'am, it is giving the reactions of aldehyde and ketone. So now we are confirmed that definitely there is presence of aldehydic and ketonic group, right? Definitely we can have a stamp on that we have the presence of aldehydic or ketonic group. Even now we are not sure whether it is aldehydic or ketonic group. So to be sure that it will have aldehydic group, let us do one more reaction. There is one more reaction to find out that whether it is having aldehydic or ketonic group, right? So in this case, basically, wait a minute. So this is bromine water, right? This is a bromine water test, right? Now bromine water test, here what will happen? This CHO group is oxidized to COOH, right? This reaction is not shown by, see, if you have ketonic group, if you had ketonic group like this, you had ketonic group like this, it's not possible to convert it into carboxylic acid because already it will have some R here, some R here. That is why it is not converted into carboxylic acid, right? We know that ketones will not get oxidized to carboxylic acid. If something is getting oxidized to carboxylic acid, that is aldehydic group, that I have told you, right? I have told you that if you have aldehyde, that will get oxidized to COH. If you have ketone, that will get oxidized to which thing? That will get oxidized to alcohols, right? Not alcohols, yes, it will not get oxidized only because you will have this kind of thing, right? Okay, so yes, we can convert aldehyde to carboxylic acid, right? But carboxylic acid for ketonic is not possible, right? Okay, it is not possible. That is why proves the presence of aldehydic group, as ketone do not oxidize in the presence of bromine water, right? In the presence of bromine water, it will not get oxidized to COH, right? That is why it is confirmed that it is a aldehydic group, right? Now we have the confirmation, it has 6 carbons. They are in the normal chain. It has one aldehydic group here. But we are not sure what are the other compounds, what are the other functional groups that are present here. So for alcohols identification, we will react this with acetic anhydride, right? That means we will react this with this thing. That is CH3, COOCOCH3, right? So with acetic anhydride, what will happen? What will happen? This CH3, this group, CH3CO, this group will be replaced by the OH, right? So what you will see, OAC is replaced by this thing, right? OAC is replaced by this thing. So basically, this thing is replaced by the H of OH, right? Basically, this thing will happen. OH is replaced by OCOCH3. In all the carbons where you have the presence of OH, it will get replaced to OCOCH3, right? That will define that you will have pentaester here. Now you can guarantee that definitely there are alcoholic group present here. There is alcohols and there are 5 alcoholic group present here because 5 OH group are replaced by the acetic acid, acetic anhydride, right? Now, after that, to understand whether how many of them are primary, how many of them are secondary, we will do one more oxidation reaction here, right? Now, here we are using strong oxidizing agent, right? If you are using strong oxidizing agent, what will happen? This OH group, that is 2 degree, that will remain as it is, right? But this primary group will get converted to COH, right? With strong oxidizing agent like concentrated HNO3, what will happen? One CHO group is oxidized to COH, and then this primary alcoholic group is oxidized to COH. That means there is only one primary group that is present here. Only one primary group that is present here, right? Okay, others are secondary, right? Okay, now next thing is, ma'am, what is this reaction? This they are just telling you that from gluconic acid that we made from oxidizing with bromine water. This we made from oxidizing with bromine water. Glucose, first it will oxidize with the bromine water. It will replace CHO with COH. Then again after the oxidation, this group, primary group, will also be replaced. Because bromine water is a mild, it will not oxidize primary alcoholic group. It will only oxidize aldehyde group, right? But concentrated HNO3, it will oxidize both CHO and primary alcoholic group. So, right, these were the reactions of identification of glucose. Now we know in the end that this is the final structure of glucose. That this is your final structure of glucose, right? Where you have one aldehyde group, where you have, this is your primary alcohol, and we have 4 secondary alcohol, 4 secondary alcohols, right? This is the final structure of glucose, right? But this is open structure. Now there are also doubts related to open structure. So we will see some of the reactions that are not given by glucose, right? But it should be given by glucose, but still it is not given by glucose, right? That is how we will think that, okay, why some of the glucose units are not giving this reaction? Because they are not existing like this. They are existing in a cyclic manner. Right? So let us see what are these reactions that are not given by glucose. Right? So glucose is concluded to have 5 alcoholic groups. This we have seen. Right? Now let us see what are the reactions. This is the structure of glucose. Okay. Now firstly, let me tell you the structure of glucose only. Right? You don't have to cram this thing. I'll tell you directly what you need to remember for glucose. Third carbon will have OH on left side. Just remember this. Just remember this thing. You don't need to cram the full, copy paste the full structure. Just remember these little tricks that I'll be telling you. Right? As you can see here, this is 1, this is 2, this is 3, this is 4, 5, and 6. Right? As you can see here, all the OH groups are on the right side, right? But this third carbon will have OH on the left side. That is why third carbon will have OH on the left side. One is your CHO group, other is CH2OH group. Primary group, there is no left or right side, right? So this is basically the structure of glucose, right? Now what is the structure of gluconic acid? You just need to oxidize this CHO to COH. What is the structure of saccharic acid? You just need to oxidize this as well to COH. This will be saccharic acid, right? Okay, understood? Now, next thing is, ma'am, what is this star mentioned here? These stars are nothing but these stars are chiral carbons, right? Because we know that in this carbon also 4 groups are different. This carbon also 4 groups are different. Here also 4 groups are different. Here also 4 are different. But in the last one, you have 2 same hydrogens. That is why this is not chiral. So in the carbon, in the glucose structure, you have 4 chiral carbons. 4 chiral carbons are present here, right? What you need to remember? That third carbon will be on the left side. Third carbon will be on, third OH group. Third carbon will have OH group on the left side. Rest of them will have on the right side. That is the structure of glucose. Right? Now, what is capital D and capital L? Right? This so we have done in optical isomerism as well. That your last chiral carbon, your last chiral carbon should have OH. If it is on the right side, it is D. If it is on the left side, that is capital L. Right? And in detail, we have covered this in optical isomerism. Right? Okay, in detail, we have covered it there. Right? Okay, so if it is on the right side, that is capital D. If it is on the left side, and we are not talking about all the structures. We are talking about last chiral carbon. Right? So tell me whether glucose is D or L. Everybody, glucose is capital D or it is capital L. Glucose is capital D or capital L. As you can see, the last chiral carbon of the glucose have OH on the right side. So it is capital D. Capital D is not dextro-levo. Right? Capital D is not dextro-levo. Dextro-levo is different thing. This capital D and capital L will just tell you that last chiral carbon will have OH on the right side or OH on the left side. If the OH is on the left side, that will be capital L. If OH is on the right side, that will be capital D. Right? Now, this is your capital D. Glucose is capital D. Right? Now, students, some of you are confused between dextro and levo. Dextro and levo is D and L. D and L will define that it is not something you can just see from the structure. You cannot identify this thing whether it is dextro or levo from the structure. This is experimental study, right? So small d means that this is your compound. Here this is a plane polarized light. So if plane polarized light is passing through this compound and it is not moving, it is just like that the same way. So the compound will be optically inactive. If the plane polarized light is moving here and after passing through it, it is rotating on the right side. That is called dextro. If it is rotating on the left side, that is called levo. Right side dextro, left side levo. Right side dextro, left side levo. Right? Okay? Understood? So here, experimentally, it is defined that your glucose is small d. It is a dextro compound. It is not a levo compound. Okay? Glucose is a dextro compound. It is dextro, that is why it is small d. It is capital D because it has on the last chiral carbon, the OH is on the right side. Now tell me, is there any confusion between capital D and small d? Is there any confusion? Right? Because after that we are also going to do alpha glucose, beta glucose. Right? So that is why I am like pressurizing on this thing. Right? Everybody. And also like this session. Why not liking the session? Right? Like this session, share this with your friends so that they can also be benefited from this. Right? Very good, very good. Yesterday you wrote the test of biomolecules. Now after that, go through that test again. Right? Very good. Now, next is, this also we have done. This is a ring structure that I was telling you that they were not happy with the open chain structure because of some things that were not right, because of some reactions that glucose was supposed to give but it was not giving. Right? So these are the straight chain structure failed to explain following properties. What are these properties? Very, very important. They can ask you what are the reactions that is not given by open chain structure of glucose. Right? So first is very, very important. 2,4-DNP test is not given. Schiff's base test is not given. NaHSO3 addition product is not formed. Right? So these three tests are not given by the glucose. Right? Now from here we can say that the COH group that we were saying that this is a free group. This is actually not free because it is not giving the test for aldehydic group. Right? Some of the molecules they were not giving. That is why open chain structure was eliminated here. Second thing is the pentaacetate of glucose doesn't react with NH2OH to form oxime. Pentaacetate of glucose. That means they are talking about this thing. They are talking about this thing, right? Pentaacetate of glucose, on reacting with NH2OH, it is not giving us oxime, right? That is why, because it is not giving us oxime. This thing is not giving us oxime. That is why we can say that this CHO group is not free. This CHO group, some molecules were giving it, some molecules were not giving it. That is why this aldehyde group is not a free group. This aldehyde group is not a free group, right? Those state chain or direct reaction form enzyme are very, very important. Those state chain on direct reaction form oxime, cyclic structure does not. Both these observations indicate absence of CHO group. Now they are saying that in open chain we have seen CHO group was CHO was converted into oxime. But when we talk about the cyclic structure, in that form, it means in the cyclic form, CHO group is not free, right? It is not free. It is bonded with some other carbon, right? So let us see what exactly is the structure, right? So here, firstly, let us talk about structure, then we will talk about alpha and beta, right? Okay. So basically, the structure is, you will have a 6-membered ring. You will have a 6-membered ring. So firstly, I will draw the structure myself only, right? Firstly, students, everybody in the chat box along with me, have your pen and have your notebook, right? Everybody, do you have one pen and notebook? I want all of you to draw it along with me, right? Everybody have one pen and notebook. It's no use if you are just seeing the PPTs and not drawing something like with your own hands, right? Okay. Okay, now let us see this. Firstly, draw the straight line. Everybody along with me do this, okay? Draw the straight line, okay? Now, I told you that how many carbons you have? How many carbons? One is CHO, other is CH2OH, other is CH2OH, right? Now, you will have how many left? 4 will be left behind. 1, 2, 3 and 4, right? Okay, I told you on the third carbon you will have OH on the left side. So it is 1, 2, 3. On the third carbon you will have OH on the left side. Others will have OH on the right side, right? Others will have OH on the right side. Now tell me, are you able to draw this structure? How many of you are able to draw this structure? Right? Is there any problem in drawing this structure? Is there any problem in drawing this structure? Because now I am going to convert this into something other. I am going to convert this into like something else, right? Okay, a cyclic ring. Now as I told you that in this case you will have a cyclic ring, right? That will be 1, 2, 3, 4, array. Okay. Yes. Okay, students, this is a 6-membered ring that you have to draw. Okay, 6-membered ring, right? Now, have one oxygen over here. Now, before that, let me draw the structure to make you understand that how this is actually converted to a structure where you have a very, very different thing. Like how this is converted to a cyclic structure. So basically what will happen, just try to open this structure, write it like this. C double bond O, this is H, right? And this is C, H, H, this is OH, right? Okay, C, H, H, OH. Now let us see what will happen here. Basically, this carbon with this last carbon, right? This carbon with this last carbon, right? They will connect together. The electrons are going to jump here. It will have a negative here, right? The electrons are going to jump here. It will have a O negative here because definitely oxygen is more electronegative, so electrons will jump here, right? Now what will happen? One of the hydrogens that will be connected here. Okay, so you can see this thing. One hydrogen from here, it will be shifted here internally, right? And to this one, what you will have? One OH will be present here because one hydrogen again will be shifted there. And here you will have a formation of this kind of ring. This kind of structure. Understood what exactly happened here? Understood what exactly happened here? To this C double bond O, electrons got shifted here. This becomes CO negative, right? One hydrogen will shift internally to that side. Like one hydrogen will shift internally to that side. It will become OH, right? And to this oxygen, what will happen? To this oxygen, because from here only to this was earlier OH, right? Here one H positive has been taken by this O negative, right? So that is why what will happen in the end, this oxygen is basically the linking unit between this carbon and this carbon, right? Okay. Okay, if you want me to draw it again, I'll draw again. Wait a minute. So basically, students, here you had C double bond O. This is H, right? And this is C, H, H, O, H, right? So what will happen here, everybody? What will happen here? Basically, the pi electrons are going to shift here, right? This will become O negative. This will become O negative. Then this bond, this H positive is going to shift from this side and attach to this H, right? So I can just draw it like this. I can draw it like this, OH, right? This is OH, right? Now, again, what will happen? This is your hydrogen here. This O will be linked to this carbon here, right? And this is the end structure that we will have, right? 1, 2, 3, 1, 2, 3, 4. Yes. Right? Okay, understood. I drew one extra hydrogen there. Yes. So this is the structure that will have. Basically, one hydrogen is shifted to that side and this carbon is connected to this oxygen. Is that clear now? Is that clear now? Right? So this is how the cyclic structure, right, will be formed, right? So if you want to write it very neatly, how you will write it neatly? You will write like this. You will write it like this. This is C, O, H, and this is oxygen, and this is your carbon, right? And here it is 1, 2, 3, and 4, right? 1, 2, 3, 4, 1, 2, 3, 4. So it is OH here, H here, OH, and this is H. This is OH only, right? This is H, this is H, this is OH, and this is H, right? This is how it will be formed. Okay, this is how it will be formed. Okay, wait a minute, let me see. Oi, so sorry. That's why I'm saying, where is the CH2OH? Like, where is the CH2OH? Wait. Wait a minute, let me draw this again. Okay, so this was C double bond O. This is H, students, wait a minute. This is CH2OH. Yes, primary will not react, secondary will react. This is OH, this is OH, this is H, and this is OH. this is H, this is OH, this is H, this is H. Yes. Again, I am explaining that because secondary will react, not primary, okay. So now here, everything else is same only. The bond is shifted here, right? Here you will have O negative, right? O negative, and the hydrogen from this one, not this one, from this one. It is shifted to this oxygen, it will be OH here, right? And then this oxygen is linked to this carbon. It's like this, right? It's like this. Now, here, if you want to draw the cyclic structure, it will be, this is a carbon that is linked to this last second carbon, and this is CH2OH. This is hydrogen only, 1, 2, and this is 3. So this is 1, 2, 3, 4, 5, 6. This is OH, H, this is H, OH, this is again OH, and this is again H, right? Okay. So this is how the structure will be formed, right? This is how the structure will be formed, okay? Yes, the last CH2OH will remain as it is. The secondary, this one will react, this one will react, this one will react, okay? This one will react, and this will make a oxygen bond here. This will make a oxygen bond here, right? Now we want to convert this into a cyclic structure. This is also cyclic structure. Now, if you want to write it in this form, what you will do, right? If you want to write it in this form, then you have to remember one more thing here. The thing is that down will be on the right side. That means you have to remember dr here again, right? That means those who you will, because here what you will form, here what will be it will be like this one, because you need to make it up and down, right? You will have one O here, right? If I am drawing the oxygen here, if I am drawing the oxygen here, this oxygen I am drawing here, this oxygen I am drawing here, right? So what you will do, this will become your first carbon, second carbon, third carbon, fourth carbon, fifth carbon, right? And here it will be 1, 2, 3, 4, 5 and 6, right? Till here we have only 5 carbons, 6 we will see where to place, right? Now, what is this dr? Dr means the OH that is on the right side, you will make those OH on the downside, right? So here on the second carbon, on the first carbon, firstly on the first carbon that is connected to one hydrogen, that is connected to one OH also here, right? One OH is also present here, so we will write one OH here, right? One OH is also present here. Now, this is connected to this first carbon is connected to one OH and one hydrogen, right? There is one more hydrogen here. As you can see, there is one more hydrogen, right? Okay. Now, there is no confusion on the OH part of this one, right? But for the second one, the OH is on the right side. Right side means it will be written on the downside, that means here, right? On the third carbon, the OH is on the left side, that means it will be written upwards. The fourth carbon, the OH is on the right side, again it will be written on the downside, right? The fifth carbon, now let us talk about the fifth carbon here. On the fifth carbon, again you have this CH2OH and there is one more hydrogen. So in these cases, what you will do, more molecular mass will be written on the upside, right? More molecular mass will be written on the upside, right? So here, on the left side, yes. So here it is written upside. Why? Because of more molecular mass and the hydrogen is present here, right? What about this CH2OH, right? This will have this CH2OH. This CH to this fifth carbon, you have two attachments. One is CH2OH, other is this hydrogen, right? Here also you had two attachments, hydrogen and OH. Here also you have two attachment, hydrogen and CH2OH, right? So these two attachments, this is having more molecular mass. So this will be the one which is having more molecular mass more molecular weight, that will be written upwards. That will be written upwards, right? So here this will be CH2OH and this is H. Now this is how you will form the alpha glucose, right? This is how you will form the basically glucose structure, right? This is the glucose structure. Again, I will repeat that. Firstly, what we did, we drew the structure of the glucose, right? After that, this first carbon, this is 1, 2, 3, 4, 5 and 6. First carbon with the fifth carbon, they will react. They will make a cyclic chain, right? And this is how neatly you can form the cyclic chain, right? Now we need to convert it into a proper cycle, a 6-membered ring, right? So first carbon is attached to one oxygen, right, with the fifth carbon. So we, in the first and fifth carbon, we have this oxygen, right? Then we have we will draw 1, 2, 3, 4, 5 here, right? Now firstly, let us write the structure. Let us write it for second, third, and fourth. For second, third, and fourth, just remember this dr. If your OH is on the right side, it will be placed downside, right? So it is on the right side, so downside. It is on the right side, it is so downside. Here it is on the left side, so upside, right? But if you talk about this first and fifth carbon, here you have hydrogen and OH. So that is why more molecular weight, right? That will be upwards. It is having more molecular weight, that is why it is upwards. It is also having more molecular weight, that is why it is upwards, right? Okay? Understood? Yes. Okay, guys. Yes. Okay. Now this is the structure. Now let us see what is alpha and beta, right? What is alpha and beta? If you talk about alpha glucose and beta glucose, they are basically anomers of each other. Like they have just one position that is different, right? So what we have seen that in this case, wait a minute, they will have this first carbon, right? This first carbon as the opposite, right? This first carbon is the opposite, right? Okay. Wait a minute, is something I'm doing wrong? No. Yeah, it is right only. Yes, the first carbon is opposite. So basically, why the first carbon is opposite? So basically, if you talk about the first carbon here, if it is on the right side, it is called the alpha. If it is on the left side, it is called the beta, right? So basically, if you talk about this carbon here, first carbon means I am drawing it in a different manner. They have drawn it in a different manner. I am drawing it like this. Okay, I have drawn it like this. They are drawing it like this. In your books, it will be like in your book, some books it is drawn like this also, right? So over here, what you can observe that on the first carbon, right, you have two things. This OH and this hydrogen, right? Okay. So now these two things, depending upon whether they are on the right side or the left side, right? Like here also we had two things, CH2OH and H. But there is no confusion that because of it is on the left or the right side, you will have a different anomer, right? But if you talk about the OH and H present here, if you talk about this thing here, if it is on the, here we can say that I am drawing two structures here, okay? I am drawing two structures here. I am just copy pasting this thing, right? So, this is your first carbon, right? If I draw the opposite here, now here OH is down and H is up, right? Now, basically, what I am writing here, if you want to draw it in different form, you can also write it like this. This is just a way of writing, right? You can also draw it like this. Okay, then you can make a hydrogen here. There is this confusion, that is why I am writing it here. OH is on the downside. That means it is on the right side, right? It is on the right side and it is on the left side. It is on the right side and it is on the left side, right? It is on the left side. So when the OH is on the right side, right, that is called alpha, right? That is called alpha. If the OH is on the left side, that will be, it is on the right side, that will be called as alpha. So here, by just this differentiation, we have made the alpha glucose here. But if I talk about, if I draw it like this, okay, if I draw it like this, just a way of representing this is different, right? If I am drawing it like this, if I am drawing it like this, right? Here the OH is on the right side. This is only first, this is not second, third, fourth, fifth, nothing. Only first I am talking about, right? If it is on the left side, now because it is on the left side, I will draw it on the upside, right? Okay, left will be upside. Now, this will be your beta, right? And this is your alpha. Okay, so three things we did. One is capital D, capital N. Other is small d, small l. Third is alpha and beta, right? So if you talk about this glucose, this is basically called as beta capital D positive glucose. Positive glucose. Why? Positive means that it is small d. Capital D means that the last chiral carbon was this one. The last chiral carbon in the open chain that was on the right side, that means it is capital D. And this beta means when you talk about the cyclic structure, right? The first chiral carbon that will have OH on the left side, right? If you talk about here, the OH is on the right side, on the alpha, and this will be called as alpha capital D plus glucose, right? Capital D plus glucose. And hydrogen, so you can write it here anyways. These are the hydrogens. Okay, so that is the structure. Now, basically this is how it was formed and this is how you can write it, right? Now, if you write it like this, that I have drawn it before, right, that is also right. But this is basically a structure where you can also define the alpha and beta, right? And alpha and beta will be defined by only this thing. Alpha and beta is only defined by this thing, right? Alpha beta is defined by this first carbon. But if you talk about capital D, capital L, that will not be defined by the first one. That will be defined by the open chain, right? If you have the open chain, in this you have CHO, CH2OH, this is CH2OH, right? And here you have, I'm drawing the alpha chain also because that structure we have changed, right? Here 1, 2, 1, 2, 3, right? This is on the left side, right side, right? This is H, this is H, this is H. Now, capital D is defined by this thing. This will tell you that it is capital D, not capital L, right? But this thing is going to tell you that it is alpha or beta, right? Or you can say this is your beta, right? And because of this thing, it is alpha, right? Okay. So three things: alpha, D, glucose, and beta. Now, glucose can never be capital L. Glucose will always be capital D only. But it can be alpha or beta. And these two are the anomers of each other. Anomers means when on one chiral carbon you have opposite configuration. That is called the anomer. Now, if you talk about open chain structure, that is called epimers. Right? If in the open chain structure you have on some position you have opposite configuration, that is called epimer. Right? When we talk about anomers, these are the cyclic epimers. Right? In the cyclic structure, right? Here in the cyclic structure it is, right? In the open structure, I am not saying. If you talk about the open structure, in open structure, now see one thing, in the open structure, these are not epimers, right? Why I am saying that? Because this is the first carbon, that is oxygen, right? This is your second, this is your third, this is fourth, this is fifth, and this is sixth, right? This first carbon has been converted to this oxygen. So here if you want to write, this was your first carbon, right? And here this first carbon, earlier there was only CHO group, right? But now this first carbon now has one OH and one hydrogen. So that means this first carbon in the open chain, there is no OH or H, right? So in the open chain, anomers Anomer, not possible. Not possible. Right? You can't define alpha and beta glucose for an open chain because in the open chain it is CHO only. But in the cyclic chain, this CHO is only converted to this C, OH and H. Now that is why this carbon will define in the cyclic chain, not in the open chain. Yes, okay. Okay, students, right? Okay. So it is important to understand that in the open chain what was happening, in the cyclic chain what was happening. This was the structure of open chain. This was the structure of open chain. Then on the first position there was no OH group, there was CHO group. But in the cyclic structure, because of the reaction of first and fifth position, right, because it will just inter-exchange the hydrogen, right, because of the pi bond polarity, right, what will happen? They will form a cyclic structure, right, and in this cyclic structure you can define this as alpha and beta, right, okay. Now because we have done glucose in detail, fructose will be easy for you, right, because fructose is same as glucose only, right, just the difference is in the ketone, fructose will have ketone and this will have aldehyde, right. So now alpha glucose crystallizes concentrated solution at 303, crystallizes crystallization of hot and saturated solution in 371, right. Here it is saying preparation is at room temperature. Here the preparation is boiling at 98 degrees Celsius, right. Now next is this, the structure we have seen only, right. Next is cyclic structure also we have seen, right. Okay. Now epimers, right. What are epimers and what are anomers, right? As I told you, epimer means on the position, right, on one carbon what you will have different configuration. So as you can see here, the different configuration is on this carbon, right, on this carbon. These are the open chain structures, right. In open chain structure, when you have on one carbon, right, you will have opposite configuration. They are called epimers of each others. Epimers is a term used in case of sugars only, right. Two sugars molecules that differ in configuration only at exit carbon atom are called CX epimers, right. On one carbon you will have opposite configurations. So now they are talking about anomers. These are cyclic epimers, right. Two sugars that different configuration only in carbon, that was the carbonyl carbon in the open chain form is called anomers. Earlier it was aldehydic group, now it is CHOH, right. Earlier it was this group, now it is converted to COH and H, right. It is converted to this thing, right, and here you had this oxygen, right. That is why here this thing is called the anomer, where that group that was earlier the carbonyl, it is converted to OH and H. Now it is having a different configuration, right. Alpha glucose and alpha fructose are known as anomers. Their equilibrium mixture contains 36% alpha D glucose, 63% beta D glucose and 0.2% open chain, right. Open chain is also present, that is why some of it. Now these are the same structures that we have already drawn, right. Now let us talk about the fructose, right. Now in case of fructose, you will have ketose, you will have keto group, right, and keto group is on the second carbon, right. So as you can see here, 1, 2, 3, here also the same thing is valid, that you will have third carbon will have OH on the left side, right. Again the same thing is valid, third carbon will have OH on the left side, it will have OH on the left side, right. So this is 1, 2, 3, third carbon had OH on the left side, rest of them are on the right side, right. In the end you will have primary alcohol, rest of them are secondary, and here you have two primary alcohols, right. And this second position you have the ketonic group, right, because ketone definitely it should have one carbon here and one carbon here, right. So that is why second position is of the ketonic, right. Now this becomes your capital D or capital L. This is capital D. Why? Because on the last chiral carbon you have OH on the right side, that is why it is called capital D, right? That is why it is called capital D. Now ma'am, is this small d or small l? So fructose is having a levorotatory rotation. That is why it will be negative. It is having capital D and negative, right? That is small l. Capital D, small l, right? That is the configurations, right? Now it is ketohexose. It is obtained along with glucose by hydrolysis of disaccharides. It is a natural monosaccharide found in fruits, honey, vegetables. It is pure form of a sweetener. Okay, in fruits we don't add sugar, no, so that is a pure form of sweetener, right? Unlike glucose, fructose is practically, it is seen that 6-membered rings are formed in a very small quantities. You will have 5-membered rings here, formation of 5-membered rings here, right? So when you will convert it into the cyclic form, right? So same thing will happen here, same thing will happen here, same thing will happen here. Let us see. Firstly, I am going to draw the structure of fructose, right? This is fructose, right? If I write this is CH2OH, 2 primary alcohols are present, right? Then I am drawing 1 ketonic group here, right? 1, 2, 3, 4, 5, 6. I think 1, 2, 3, 4, 5, 6. Wait a minute. 4, 5, 6. Now 1, 2, 3 on the third position you have OH on the left side, right? Rest of them are on the right side, right? This will become the open structure of fructose. This will become the open structure of fructose. Now we are doing the same thing here, right? We'll do the same thing here. We are converting this into the cyclic structure. Again the same thing. Here the pi electrons of this double bond, they will shift here, right? And this hydrogen, this carbon will be now linked to this oxygen, right? And they will form a cyclic structure which have 1, 2, 3. Wait a minute. It will be like this to this one, or you can see like this. It will have 1, 2, 3, 4, 5. 5-membered ring is formed here, right? So how 5-membered ring is formed here? Firstly, let us see how the cyclic structure will look like. It will be CH2OH, right? It will be CH2OH. Firstly, I am drawing from this thing only, then we will like rearrange this thing, right? So firstly, I am drawing it CH2OH, CH2OH, CH2OH. Rest of the thing is here you will have an oxygen bond, right? That is bonded here. That is bonded here, right? Now, this is carbon, this is oxygen, right? To this you will have one OH, right? To this you will have one OH. This is 1, 2, 3. This is hydrogen. This is OH. This is OH. This thing I am drawing here. This is OH. This is hydrogen. This is not OH. Wait a minute, because it is shifted here. Only 2 bonds will be formed. Wait a minute. Let's draw only 2 things here, 2 bonds here, because this is already shifted. So only 2 things are intact here. That is this OH here and this hydrogen here, this hydrogen and this OH here. Right? Now I am going to rearrange this into what you will see in your books. Right? So this is the structure. Right? This is the structure, right? I'm going to rearrange this now. Now, this is CH2OH, right? And this is, because here the carbon will have one CH2OH and one OH, right? So I'm writing it like this. One oxygen is bonded here, right? And this has 1, 2, 3. This is same as OH, hydrogen. This is hydrogen. This is OH. And this one is, you can write it in 2 ways. CH2OH and this is OH. Right? CH, whenever you have OH on that position, it will define that whether you have alpha or beta, right? Okay, so now this will become the structure, right? This will become the structure, right? Let us see how to convert this full structure into the cyclic ring, right? So it is having 1, 2, 3, 4, and this is 5. Okay, so I'm going to copy paste this thing and let us draw the same structure on the next page, right? How we will draw the cyclic structure on the next page, right? So you should draw a 5-membered ring here. A 5-membered ring you will draw. A 5-membered ring you will draw, right? This is your 5-membered ring that you will draw, right? This is the oxygen that you will draw here, right? This is the oxygen. Now see one thing. This is the oxygen that you will draw here. If I write this as my first one, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, right? Because that primary, I'm going to write it here as well. If I move it in this direction, this is 1, 2, 3. So I'll be like 1. 1 is not in a position. It is not in the chain, right? So it will be like this. 1, 2, 3, 4, 5. Right? So first is on this position, CH to OH. And then you have OH here. Then you have OH here. Right? Here you have CH to OH, then OH. Then on the second position, you have one OH and CH to OH. On the third position, because this is my second, this is my first, this is my second, this is third, this is fourth, this is fifth, right? So on the second position, I'll also give you tricks here. First, I'm just telling you how to draw the structures, okay? So this is CH to OH, this is OH, right? Then on the third position, you have OH on the, here I am doing nothing. I'm just telling you here, I'm just doing, this we will talk about in the next page also. Firstly, let's focus on third, fourth and fifth carbon, right? Third carbon OH is on the left side, right? Left side means upwards, right? Right side means it is downwards, right? Again, on the fifth carbon, what you have? On the fifth carbon, you have one hydrogen and you have one CH2OH, right? You have one carbon and you have one CH2OH, right? Now, I have drawn it 1, 2, 3, 4, 5, right? In some books, they could have written 1, 2, 3, 4. In that case, it will be completely opposite, right? In some books, they can also write it as this thing. Wait a minute. They can also write it as this thing. Draw a 5-membered ring, right? Draw a 5-membered ring with the oxygen in it, right? Once you draw it, you will have one up and one down, right? One up and one down. Try to draw it on your books, all your notebooks as well. Now, if I say that I want to write one from this side, if I want to go it like this, so it will be 1, 2, 3, 4, 5. Then I can draw first position CH2OH, right? This is OH, right? Third position you have OH and H. Fourth position you have H and OH, right? Fifth position you have CH2OH and H, right? Here you are in the fifth position. There are two ways that you can see in the books, this way or this way, right? So don't get confused, because in the books it will not be mentioned that it is 1, 2, 3, 4, 5, right? In the books 1, 2, 3, 4, 5 will like rarely be mentioned, right? What you need to, because in fructose students get confused in this because it is having 2 COH group above, right? So how you can identify which they are telling you this thing or this thing, which is the second, which is the first one, right? So I would advise you just take one of them as what you want to draw in your notebooks. Some students draw it this way, some students draw it this way. I would advise you this way, because in most of the books you will see OH, CH2OH like this, okay? Now, on the fifth carbon, there is one hydrogen and CH2OH. On the second carbon, there is one OH and CH2OH, right? So, when you have OH in comparison to something, that OH is going to define whether it's alpha or beta, right? Okay. The same way we did for glucose as well, right? So let us see this. So here, as you can see, that alpha glucose is defined by, this is the same as glucose. Fructose is same as glucose. So now, alpha is when OH is on the right side, right? Beta is when OH is on the left side. Rest of the things is same, right? Rest of the things is same. This CH2OH, right, this will not define. This thing will define. So don't get confused here, right? So for example, I'm just copy pasting this thing because we want to draw alpha and beta. So now, here as you can see, this CH2OH is on the right side, right? OH is on the left side. Is this alpha or beta? This will become beta because alpha, this thing will define, okay? This thing will define the anomers here, this thing, right? So as the OH is on the left side, so we can say that it is a beta fructose, right? So here we have drawn the same thing. The OH is on the left side, sorry, the OH is on the left side, that is why it is downwards. The OH is on the left side, that is why it is downwards. You can also write it like this or write it like this. This is the same thing, right? This is how beta fructose will be written, right? This is how beta fructose, this is basically beta capital D negative fructose. Okay, this is beta capital D negative fructose. If you talk about alpha, that will be the OH is on the right side. The OH is on the right side. So it will be, wait a minute. So it will be OH is on the right side, OH here, and here you have CH2OH, right? Here also things will change on the second position. Don't change it here on the second position because both have CH2OH, CH2OH. Okay, so it will be CH2, this will be opposite, right? OH here and CH2OH here. Because OH is on the right side, that is why right means, wait a minute. Here OH is on the left side, so OH should be upwards. Wait a minute, OH should be upwards here, okay? OH should be upwards. OH should be upwards here. Because DR, right? On the right side, that means down. So it is on the left side, that means it is upwards. So it will be like this. It will be OH here and this is CH2OH. This is your beta, right? This is your beta. If you talk about alpha fructose, now this is going to be on the right side, right? That is why it is your alpha. Now, this is your alpha because it is on the right side. So second position, OH is on the downside, okay? OH and this is CH2OH. Here also OH, CH2OH, right? Because downwards means on the right side, right? So on the right side, that means downwards, okay? Okay, everybody, let me check if all the other things are right or wrong. So third is on the right side means downwards, right side means downwards, right? Here the more molecular mass will be upwards, right? Here also let me check, right? That was the same thing only, right? So this is your alpha capital D negative fructose. Mostly you will use alpha glucose and beta fructose, right, while making polysaccharides. Okay? Yes? Okay? So let me check that again. Let me check glucose as well. Even hurry sometimes, no? Okay. First carbon downwards, second carbon downwards, third carbon downwards, fourth carbon downwards. Yes, that is right. Okay, that is right. And what about this one? First carbon, hydrogen downwards, OH downwards, here H downwards, right? OH downwards, and again this is also right. Okay, so glucose and fructose structure we have drawn here. Okay, guys? Okay, guys, so you just need to remember one thing. Even if you don't remember the full structure, that is okay. You just need to remember this thing, right? That from this position, it will make a bond, right? After that, you just need to rearrange this CH to OH here. Now, this rearrangement will define the alpha and beta glucose, right? So, here you will have alpha fructose and beta fructose, similarly alpha glucose and beta glucose, right? Okay. So, basically anomers, again when I am saying that the carbonyl group that were earlier the carbonyl group, that is converted into OH. Now, that OH is going to define whether you will be having alpha or beta, whether it's glucose or it's fructose, right? Okay. Yes. Now, next thing is cyclic structure of this, so we have done, right? So, we have done. Now, they are saying that exist in two cyclic forms which are obtained in addition from this to this. Formed is a 5-membered ring. It is named as furanose, like glucose is pyranose, right? This ring is furanose. In glucose, the ring is pyranose, 6-membered ring. And here it is 5-membered ring, so it is called furanose, right? So, furan is a 5-membered cyclic compound with 1 oxygen and 4 carbon atoms, right? This too we have already drawn, right? Alpha glucose, on alpha you have OH on the right side, that is why the OH is downside, right? Here they have written it like this, 1, 2, 3, 4, right? I have defined both the structures, even on right side, even on left side, right? Here it is beta, on beta OH is on the left side, left means upwards. So here it is upwards, right? And this is the furan. This is furan, so you all know, right? Now, next is sucrose. Now, these we are talking about disaccharides. So, now once you have understood glucose and fructose, now disaccharides is going to be very simple for you, right? One thing to note here, galactose has a position changing with glucose only. Galactose is like glucose only. You don't need to study galactose like individually. Galactose is same like glucose. It's just and on the 4th carbon, the configuration is opposite. That I'll show you, okay? So, here, disaccharides, you don't need to remember this full diagram here. Just remember 2 things here. That what is the structure, right? What are the 2 compounds, monosaccharides you are using and to which there is linkage, right? So, now here we are saying that the linkage is between alpha glucose and beta fructose. Now, we all know how to draw beta glucose, alpha glucose and beta fructose. Now, what will happen when two monosaccharides are combining? They will lose water. One of the students was saying that, ma'am, it will lose water. It will not lose water when we are forming the cyclic structure, right? Cyclic structure is just the rearrangement of hydrogens, right? That is not, water is not be eliminated in that. Water will be eliminated here when you are forming disaccharides, right? So, this sucrose is a disaccharides of glucose and fructose. So, water will be eliminated from this side. How? They are saying that the water is, this is very, very important, from C1 of alpha glucose and C2 of beta fructose. That is why I told you, you should know how to write the structures, okay? Now, see one thing. You should know this thing also, you should know this thing also. That is only possible if you know this thing, right? Why? If you know how to draw this structure in a Fisher projection kind of structure, now you can use a proper furanose structure here. How? Why this is important? Because now we know that we need to eliminate water from second carbon. If you draw this structure, it will be very difficult for you to draw it, right? I'll also show you how to draw it with this structure, right? Now, in some books, they have taken up this structure. Now, how to take up water from there? Very simple. See this, you have this glucose, this is fructose, right? On the glucose, wait a minute. This is the fructose. Where is starch? Wait a minute, where is starch? So, this is glucose and this is fructose, right? They are saying from the C1 position, this is the C1 position, right? I can also write it here, 1, 2, 3, 4, 5, 6, right? If you want to write this, if you want to identify whether this is C1, C2. Now, how they have identified and how they have drawn the linkage is very weird, right? So, I will draw it myself only, right? Now, what I will do here, I'll just erase this thing, right? I'll just erase not everything here, right? Now I am changing the positions here, right? I am changing the positions here. How I'm changing the positions, right? I am changing the positions here, okay? Now, if you want to write beta glucose, we want to write it in this form, 1, 2, 3. So on first position, beta means the OH is on the left side. Left side means it is upwards or downwards. It is upwards or downwards. Everybody, it is upwards or downwards. It is upwards, right? So here we will write it like this. This is OH. Wait a minute. This is OH, right? This is OH, right? They are saying it is between C2 over here, right? So this is C1, C2. C2 is what? This is CH2. This is CH2OH because this is beta, no? So then we have on beta, this is first, this is second. This is first, this is second. On the third side, you have OH on the left side, right? So that is again upwards, right? Then you have on the right side. On the right side, it is OH here, right? On the fifth carbon, you have CH2OH and this is H, right? So this is how beta glucose will look like, right? Okay, this is how the beta glucose is looking like. Now, you are eliminating water from here, right? Water is eliminated from 2 OH groups you need to eliminate water. Now here OH will be eliminated, here H will be eliminated, and you will have a linkage of this thing. You will have a glycosidic linkage here. Like you will have a glycosidic linkage here, right? This is the glycosidic linkage that you will form here, right? That is why what we will write here, wait a minute. I feel that something they have written here is wrong. On the second position, right? The structure here is wrong. Wait a minute. R beta glucose. Wait a minute. Let me see the structure of beta glucose. OH, H, OH, right? We have drawn that thing only, right? OH, H, H. So this structure is wrong. Let me rewrite the structure here. I am rewriting the structure here, right? Okay. Let us see what will happen here, right? Okay. Now let us see what will happen here. This OH from here and this hydrogen from here will be eliminated, right? And hence in the end what you will have? This is H. I'm just erasing everything here, right? So that we can write the structure like how you can write it, right? In a bookish language, I don't want you to cram it in a bookish language, okay? So this is CH2OH. This will be written here as it is CH2OH. This is hydrogen as it is, right? This is OH. This is H, right? This is again H. This is OH, right? Now you have seen the difference here. OH from here and H from here. That means the glycosidic linkages will be like this. It will be like this, right? And here you will have one hydrogen and here you will have one CH2OH. CH2OH. That is the glycosidic linkage that you will form here, right? Okay, that is the glycosidic linkage that you will form here from C1 of alpha D. C1 we have used and C2 of, this is first, this is second, wait a minute, this is first, this is second, this is third, this is fourth, fifth and sixth, right? So on the second, C2 of beta D fructose, right? They will eliminate water and you will have this structure that is called sucrose, right? Okay, understood? Yes, it's not a difficult thing. It's just that you just need to remember that what is the glucose or fructose or galactose you are using, then eliminate water from those two sides, right? Okay. Now, very important thing, sucrose is a non-reducing sugar. That means it is not reduced by Tollens test or Fehling test, right? It is a non-reducing sugar. Now, next is sucrose is dextrorotatory, but after hydrolysis, now sucrose is also called as invert sugar. Why it is called as invert sugar? Because if you talk about sucrose, that is a dextrorotatory compound, but on hydrolysis, it will give you glucose and it will give you fructose. Now, glucose is positive, that means dextro. Fructose is levo, right? But what will happen? The rotation of fructose is more than rotation of glucose, right? That is why when sucrose is hydrolyzed, it is converted from dextro to levo. The amount is not, I'm not talking about the percent, I'm not talking about the percentage, I'm talking about the amount of rotation. The amount of rotation, fructose will have more rotation. That is why it is converted to levorotatory, right? Hydrolysis of sucrose bring about a change in the sign of rotation to levo, and the product is named as invert sugar. That is why we call it invert sugar, right? Because it is inverting it. It is changing the sign, right? Okay. Next is lactose. Now, lactose that we find in milk. Now, in this basically we have two things. One is galactose, right? One is glucose. Now, galactose and glucose are almost same. It's just the position of C4 carbon, right? I'll show you what is the difference. So, here you write 1, 2, 3, 4. This is the fourth. 1, 2, 3 and this was the fourth. Oi, they have not written the fourth one. Chalo, I'll write the fourth one here, right? Chalo, I'll draw it here only, right? So guys, here you will have one oxygen, right? It's like this, right? If you talk about 1, 2, 3, 4, 5, right? Now, on the fifth one, you will have CH2OH and one hydrogen, right? Okay, so this is 1, 2, 3. Third, you will have, it is on the left side, so it will be upwards, right? Fourth, it will be on the right side only, so it will be downwards, right? What about this first and second, right? So in the first, you had this linkage here. On the first, it is alpha, they are saying. So alpha means the OH is on the right side. Right side means it is downwards. So right, so OH will be here, right? And on the second carbon, it was again on the downside only, on the right side only. So it will be like this. Let me see. Right? Okay. So that was the structure. Right? Beta glucose they are using. Achha, beta glucose they are using. So sorry, I thought alpha. Beta. This is the alpha, no? So if we talk about beta, beta will have first carbon OH on the left side. Left side means upwards. So OH is present here. Okay, you just need to remember that on the third carbon OH is on the left side. Rest of them OH is on the right side. But if you talk about C1, their OH will be on the right, on the alpha beta. This is beta. Here OH will be on the left side. Left side means upwards. Okay, so you just need to remember that third carbon OH is on the left side. That's it. This carbon, it will depend on whether it is alpha or beta. They are saying alpha, they are saying beta glucose and beta galactose. So now let us draw the glucose again. Right? This is O, right? Let us draw the glucose again. From there only we will draw the galactose, right? You don't need to remember galactose like individually, right? So here, beta only they are saying, so OH will be upwards here. Third is downwards. Third is on the left side, that means upwards. Rest of them were on the right side, that means downwards, right? This is CH2OH. Here you will have one hydrogen, 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 hydrogen. Now both of them are beta glucose. Now if you want to write beta galactose here, you just need to change the fourth position. This is the fourth position. Just change the configuration here. Just change the configuration here. It is OH here and H here. That's it. You just change the configuration. This will become galactose. This is beta galactose. Beta galactose. Right? This is glucose. This is galactose. The only difference is on the fourth position. On the rest of them are same. If they talk about alpha, you will change this side. You will change here. OH will be downwards. H will be upwards. Okay? Understood? What is alpha? What is beta? What we are doing here? Right? So that is galactose. The difference is on the fourth position. Right? Alpha, beta, the difference. Alpha glucose, beta glucose, the difference is on the first position. Glucose and galactose, the difference is on the fourth position. Okay? Understood? Understood, guys? Yes. Now, we need to just eliminate water from here. Right? So now they are saying from C1 of galactose and C4 of glucose. C1 of galactose. Right? C1 of galactose means this position. This is 1, no? This is 1, 2, 3, 4, 5, 6. This is 1, 2, 3, 4, 5, 6. Now, you need to eliminate water from here. What we will do? This is OH, this is H. Right? So, this OH and this H, right? They will form a glycosidic linkage here. They will form a glycosidic linkage here like this. Okay, this is the glycosidic linkage that will be formed. Rest of the things will be same. Okay, rest of the things are going to be same. Okay, just eliminate water from here. This is the glycosidic linkage between C1 of galactose and C4 of glucose. Now this you have to remember that which C1 you are using, which C4 you are using. Right, C2 you are using or what you are using. This you have to remember. Right? Okay. You don't need to cram this structure, but you need to remember this linkages. Even in the NEET exam, they will not ask you the full structure. They will only ask you the linkages here. Right? They will ask you the linkages. They will not draw a structure. They will not ask you to draw. This is an objective exam. That is why this thing is important for you. Right? Next is lactose. Lactose, so we have done. Lactose only we did. It is more commonly known as milk sugar because it is found in milk. It is composed of beta-D-galactose and beta-D-glucose. Free aldehyde group may be produced at C1 of the glucose unit. Hence, it is reducing sugar. Right? Now, they are saying that if you talk about C1 of glucose unit, this thing, C1 of glucose unit, after reduction, a free aldehyde group can be produced here. That is why it is a reducing sugar. Right? That is why it is a reducing sugar. Right? Basically, it gives positive test for tolerance reagent. Right? Next is maltose. Now, maltose, right? Maltose is formed by the glycosidic linkage of alpha glucose units. Right? And here, what are these glycosidic units? You have alpha glucose only here. C1 of one alpha glucose with the C4 of the other alpha glucose unit. Right? So, we will make two alpha glucose unit. I am just copy pasting this thing, right? Because alpha glucose we have already made here, right? So, this is your alpha glucose, right? Let us make alpha. Okay, if you want to make alpha here, what is the difference that you will do? If you want to make alpha here, you will replace this because in alpha, OH is on the right side. Right side means downwards, right? Okay, right side means downwards. So here OH is downwards. First thing is you need to check on this thing. Second is they are saying that this is glucose, no? So H and OH, the fourth will be downside only. It is like this. So we have two units of alpha, right? They are saying C1 of one and C2 of other. C1 of one and C2 of other, right? So again, what will happen? This is OH, this is OH, both are on the same side. So OH from here, hydrogen from here, they will have a linkage like this. This like kind of linkage you will see, this kind of glycosidic linkage you will see in maltose, right? 2 alpha units. This is alpha glucose, this is also alpha glucose, right? This is also alpha glucose, right? Okay? Yes. Now, that is the thing that you will see here, right? That is basically called maltose. Free aldehydic group can be produced. That is why this is also a reducing sugar. Basically, disaccharides are reducing only, right? It's just that sucrose is a non-reducing sugar, right? Disaccharides, you will see they are reducing only, right? But when you talk, sucrose is the exception. That is why sucrose is asked, whether it is reducing or non-reducing. So sucrose is non-reducing, right? Others are reducing only, right? Next is polysaccharides. So in polysaccharides, also you don't need to learn the structure. Nothing will be asked to you. Just the linkages will be asked to you, right? So basically, polysaccharides means starch, cellulose. These are the polysaccharides. So if you talk about, it contains large number of monosaccharides joined together. If you talk about starch, it has alpha glucose. The units are alpha glucose, right? Now it is also of 2 types, amylose and amylopectin. The difference is in the linkages, not the units. Both are having alpha glucose only. The difference between amylose and amylopectin is in the linkages that it will have. So if you talk about the linkage of amylose, here you will have C1, C4 linkages, right? There is no branching here, right? C1, C4 linkages will be, basically it is a polymer of maltose, you can see. In maltose also you had which thing? C1, C4 linkages of glucose. Same thing you will have here. C1, C4 linkages of glucose, but here it's not just 2 glucose units will combine. N number of glucose units will combine to have C1, C4 glycosidic linkages from the alpha glucose units, right? From the alpha glucose units, right? Okay? Yes. Yes, I'll drink water. Just give me a minute. Yes, what is amylopectin? Amylopectin will have branches also. Basically, it will have alpha D glucose units which contains formed by majorly, it will be C1, C4, but it will also have C1, C6, right? Alpha D glucose in which chain is formed by C1, C4 glycosidic, whereas branching occurs by C1, C6 glycosidic linkage, and this is very, very important. That in amylopectin, you have branching. Amylose is a straight chain, right? It is having only 1 and 4 linkages. But here, if you talk about this first here, and this is the 6th, it will also have the linkages of 1 and 6. It will definitely have 1 and 4, but it will also have 1 and 6. That is why there will be branching, right? Amylose and amylopectin. Amylose 1,4, amylopectin 1,4 and 1,6, right? Amylose 1,4, everybody in the chat box. Amylose 1,4, amylopectin 1,4 and 1,6. All are having alpha D glucose only, right? Next is glycogen. So glycogen is also somewhat similar to this only, right? With more branching. Let us see that. Carbohydrates are stored in animal body as glycogen. In animal body, the carbohydrates are converted into glycogen and they are stored in our body. So basically, it's a source of energy, right? Whenever you feel that you are not, like for example, you are on a fast, right? So when you are on the, they can ask you 2 to 3 questions from here. And this is also there in your biomolecules of bio. That is why not only here, they can also ask you 4 to 5 questions from there, right? So together it will give you a lot of marks, right? So now if you talk about this thing here, it is basically a source of energy in your body. So known as animal starch because its structure is similar to amylopectin and is rather more highly branched, right? As I told you, it is same as amylopectin. The branches are same. It means C1 and C4 of glucose, C1, and C6 of alpha D glucose. But here also one more thing to remember, that there will be more highly branched. This is linkages are same, only branchings are more, right? It is more highly branched, right? More linkages are of 1,6. Now this is your glycogen, as you can see here, right? This is 1,4, this is 1,6. Further you have 1,4, 1,4. Further you will have 1,6, right? So this will go on increasing, and more branching will be there, right? So it is present in liver, muscles, brain, where the body needs glucose. Enzymes break the glycogen down to glucose, right? Okay. So basically, as I was telling you, when we are on fast or we don't have energy, right, our body will somehow manage. You will not give it carbohydrates by eating. You will not give it carbohydrates by consuming something, right? But still it will be able to survive few days. How? From this glycogen. The glycogen stored in your body, that will break down into glucose, and that will help you to get energy and to work, right? But this will not, once the glycogen is gone in your body, then, right? Okay. Next is cellulose. Starch we talked about. Starch is amylose and amylopectin, and amylopectin is also similar to glycogen. Now let us talk about cellulose. It occurs exclusively in plants and most abundant organic compound. It is predominant constant of cell wall of plant cell, right? In the cell wall of the plant cell, you will have cellulose. You have seen the cells, right? In the plant cell, you have a definite thing that is called cellulose. Cellulose is a straight chain, right? As you can see here, composed only of beta D glucose, right? It will have the linkages of C1 and C4, right? Very, very important, C1 and C4, and it is only consists of beta D glucose. Starch is of alpha D and cellulose is of beta D glucose. That is the difference between both of these. Starch alpha D, that beta D. Starch has amylose and amylopectin. Amylose has 1,4. Amylopectin has 1,4 and 1,6. Glycogen is also like amylopectin, but it has more branching. Okay. From this, the questions are asked. Okay. In your previous year questions, you will see direct questions are asked on the linkages. Right. Okay. Next is amino acids. Right. Carbohydrates we have completed. Now let us talk about the amino acids. If you talk about the amino acids, right, they are basically, they consist of COH group and NH2 group. These are the amino acids, right? So it contains amino, that is NH2, and carboxyl, that is COH group. Both the groups are present here, right? So you will have a lot of amino acids here. But if you talk about the property of amino acids, they will form the zwitterion. How? Because this is a basic form. We talked about amino acid zwitterion also in amines, right? So what is this? This is acidic. So it will give its H positive to this side, because acid wants to donate H positive, base wants to gain H positive. It will donate H positive here and it will become RCHCOO negative NH3 positive, and this is called zwitterion. This is called zwitterion, right? There are a lot of amino acids in your syllabus and you need to learn them, right? So now alpha. Now what is alpha amino acid? When on the alpha position, that means where the COH is connected to that alpha position only NH2 is connected. That is called alpha amino acids, right? So depending upon that, we have various amino acids like alpha, beta, gamma, and so on, right? So now let us talk about zwitterion. This we have already talked about, that it will lose H positive to the base and it will form a zwitterion here. Now this is very, very important, right? Very, very important. This is a chart. Yes, you have to remember this, right? So some of you, I'll tell you that leucine is important, right? Then vanillin is important. Isoleucine is important. Lysine is very, very important. Glycine is also very important, right? Alanine is also very important, right? So all of them are very important, right? So basically, you need to remember the structures here. What is the R chain here? Here R is H, here R is CH3, here R is here R is CH3 twice CH. Right? Here R is CH3 twice CH, CH2. Here R is CH2, CH3, CH3, and this is CH. Here this is the R functional group. This is R. Here this is R. Right? So basically, they can ask you lysine. If you want to still shortlist that, ma'am, what is like not to miss amino acid. Firstly, though, you need to remember all of them, but still if you want to have the most important, first is lysine, then there is alanine, glycine, right? Then they can ask you about basic, and they will not ask you structures based on these, but they can ask you basic and acidic amino acids here, right? So structure of glycine, alanine and lysine are very important. Next are aspartic acid is also very important. Then serine is very important. Then cysteine is very important, right? Then you have glutamic acid is also important, right? So these are some of the important amino acids, right? The structure of these amino acids are important for you. Rest the structures are important, no doubt. Asparagine is also important to you. Glutamine is also important, right? I'm not saying that these are not important, but yeah, these are the must for chemistry. For bio, you need to remember all of them. I think for bio, you remember all of these, isn't it? In bio, I think Baswasa told me that in bio, you need to remember all of them. Hai na? So you're remembering this for bio, you don't need to remember this for chemistry because you already know the structure of them, right? Now, here histidine is important, right? Then yes, okay, these are very, very important amino acids. Now, let us talk about the classification, acidic, basic, right? So now, if the number of amino groups are less and carboxylic are more, that is acidic. If amino and carboxylic group are same, that is neutral. If amino group is having more number, then we will say it is basic in nature. So this they can ask you which is acidic, which is basic, as you can see here. As you can see here, in lysine, lysine is basic in nature. This question has been asked because you have one NH2 group extra here. Right, one NH2 group is extra here. That is why lysine is basic in nature. Glutamic acid is acidic in nature. That is why it is acid, no? Right, here also you have one more CH2. Again, it is acidic in nature. Now, this glutamic acid is basic in nature. Why it is basic? It has more NH2. Right, asparagine is also basic in nature. It's also basic in nature. Right, then you have that's it. Yes. So mostly they will ask you regarding glutamic, asparagine or lysine, right? Whether they are acidic or basic in nature. Yes. In bio you have all of them, then to remember all of them, right? All of them are very, very important, even asked in chemistry, right? Okay. Next is this acidic or basic. Definitely they can ask you question from there. Next is classification on amino acids based on essential and non-essential, right? So essential are which cannot be synthesized in our body, right? So that is essential. We need to have it from the outside. Non-essential is which can be synthesized in our body, right? Which can be synthesized in our body, right? Okay. Now, next is proteins. If you talk about proteins here, proteins are the polymers of amino acids. If you combine a lot of amino acids, n number of amino acids, they will form a chain that is called the protein, right? And protein also has primary, secondary, tertiary, and primary and quaternary structure. 4 structure it will have, and they can ask you from these 4 structures, right? Now, if you talk about primary, secondary, this is basically they are telling you how protein is formed. For example, you have this is a peptide bond that is formed between the 2 amino acids. How it is formed? right? So this is glycine, this is alanine, right? So this compound is glycine and here you have alanine, right? What will happen? The OH of this and the H of this, right? They will take out water from there, right? So OH and one hydrogen from here, that will be eliminated. It will form C double bond O, NH, rest of the things will be same. Now after taking out water, the linkage that is formed here is called peptide linkage. In carbohydrates, when they used to eliminate water, that was called glycosidic linkage, and this is called peptide linkage. Okay, this is called peptide linkage, right? This is called peptide linkage. Now, dipeptides, tripeptides, tetra and polypeptides. If you talk about 2 amino acids when they are combining, that is di, 3 amino acids, that is tri, 4 amino acids, that is tetra, if many amino acids, that is polypeptide. Now protein is a polypeptide structure because n number of amino acids will combine, right? Hydrolysis of peptide, that will give amino acids, this so we know, right? Next is proteins are divided into 2 parts, fibrous and glabrous. This is basically based on the tertiary structure only, right? Fibrous, they are insoluble in water. In our hair, for example, you are taking bath, right, and you wash your hair. Are they soluble in water? If that is so, you will lose, like you will be bald every day, right? You will lose water every day because our hairs are not soluble in water. Our nails, they are not soluble, right? Even if you put your hand in water for 10 days or something, right, your mass will have some kind of shrinkage, but your nails will stay as it is. Nails will not get soluble that, okay, so much water for 10 days, I'll get dissolved in the water, right? Nails will stay as it is. Your hair will stay as it is, right? Now, that is the reason why this is so, because they are insoluble protein form. Keratin. Have you gone to any hair spa or something, right? You must have heard about keratin treatments, right? That they will give you keratin in your hair. Keratin is basically a protein, right? So they can give you protein artificially. So this keratin is present in our hair, right? That is making it strengthen, right? That is why this keratin is insoluble in water. That is why our hair are not soluble in water, right? So polypeptide chains run parallel and held together by hydrogen and disulfide bonds. The fiber-like structure is formed, right? So basically, if you talk about the structure of these proteins, polypeptide chains run parallel and held together by hydrogen and disulfide bonds, right? But if you talk about globular, chains coil around to give spherical shape. Coil around means this kind of shape, right? They will like coil around, right? Mix together with each other, right? And they are soluble in water, right? They are soluble in water. In our body, we have proteins, they are soluble in water, right? Insulin, albumins, right? These are soluble in water, right? In our body, right? We eat some protein because it is soluble in water. That is how it is being digested in the body, right? Okay. Now, next is structure of protein. So, we have 4 structure of protein: primary, secondary, tertiary and quaternary. Wait a minute. You have 4 structure of proteins. If you talk about primary structure of protein, what is exactly the primary structure of protein? Okay, so let us see that here. You can just understand it like this. For example, here the atoms, there is peptide bond. This was one amino acid, this was other amino acids. Now they have formed a bond, right? That is a primary linkage, right? When there is formation of peptide bond, and because of that peptide bond, they have formed a chain. That is called the primary bond, right? That is called the primary structure. Each polypeptide in the protein has amino acids with each other. The sequence of amino acids that is said to be primary structure of that protein, right? How peptide chains, how, not peptide chains, how you can say how the amino acids are linked to each other. That is primary. Now, when we go to secondary, the complexity is going to increase, right? I tell my students this is like a snake theory, right? Made by your ma'am, right? Snake theory. You know a snake, right? How a snake is formed, right? By combining the atoms with each other. But mass of the snake is combined. This is how the snake is formed. Now, the snake is the peptide. Snake is the amino acid chain formed by a peptide bond, right? Now, for example, that snake is now what is happening? Secondary structure is when the complexity is increasing. That means it is also alpha helix and beta plated. So now let us see what will happen. Once you have formed amino acids are linked together, right? They have formed a peptide bond and they have a chain, right? That is the primary. Now in the secondary structure, the folding backbone of, wait a minute, this arises due to folding of the backbone of the peptide chain to hydrogen bonds. Alpha helix is like a right-handed screw. So basically two kind of structures you will have. One is alpha helix. It's like this. This is alpha helix. It's like this. It's like a spring, right? This is alpha helix structure. Now what will happen? Firstly, though, I was telling you, wait a minute. Let me see if I have something here. Okay, I have no spring here. Chalo, no issues. Okay, so I'll show you here only, right? So, for example, primary is when this is one group, this is the other group. They are joined together by the peptide bond. This is primary. Now, so many peptide bonds are joined together. So many amino acids are joined together, right? So many amino acids are joined together. This is like the dancing of the snake, right? So snake, how the atoms of the snake are joined together, that is called the primary structure. How the snake is like moving, dancing like this. The snake is dancing like this. That is the secondary structure. Sometimes, have you seen any snake like in your life? Sometimes the snake can also fold itself like this. Okay? Some big snake can also fold itself like this. Sometimes you will see the snake like this. Sometimes the snake will be like this, like this. So these are the ways in which the snake is moving, right? In which the snake is moving. So secondary structure is basically, it's not a new bond formation. We are just saying that because of the hydrogen bondings here, instead of a straight chain like this, like it is not like this, the secondary structure is not like this, right? This is the primary structure. Firstly, we are just telling that it is made of peptide bond. Now the snake is also moving. Now the snake can move like this, right? The snake can move like this, right? The snake can move like this. So based on how the snake is moving, that is the secondary structure, right? So basically there are two types of secondary structure. One is alpha helix. This is alpha helix, right? Like a spring. Other is beta pleated. This is beta pleated, right? This is the beta pleated structure, right? The beta pleated structure where it is parallel. Alpha helix is like a spiral. It's like a spiral. It is moving like this. It's like a spiral. Okay, it is like a spiral. So secondary structure arises due to holding of this is this because of hydrogen bonding. In beta pleated structure, peptide chains are stretched out to maximum extension and they joined by intramolecular hydrogen bonding. Basically, they are kind of parallel to each other, right? That is the beta structure. Next is tertiary. In the tertiary structure, you can assume a snake in a pipe, right? So, for example, we are saying that it's not only one snake, 2-3 snakes, they are combined together, right? So, it represents overall folding of the peptide chains, further folding of the secondary structure. It gives rise to two major molecular shape, fibrous and globular, right? This is how fibrous and globular protein is formed, right? So, further complexity is done here. Now this is the further complexity. This is your peptide. This is, for example, your protein is in the alpha helix structure. In the alpha helix structure, right, further it is getting fold. For example, you had a really large, so I'm showing it like this. Okay, you had a alpha helix structure, right? Alpha helix structure. So now the alpha helix structure, how it is arranged, how this alpha helix structure is arranged, right? This is called the tertiary. Okay, let me draw it again. Primary, secondary, tertiary, right? Primary, secondary, tertiary. If you talk about the peptide chains, this is the peptide chain. This is the primary structure. Then I am saying how it is with the, because of the hydrogen bonding, how it is making bond and giving itself a shape, right? Because of that hydrogen bonding, there is formation of a shape. Now, this is in the shape, but further, if you zoom it out, if a large number of peptide chain, it is combined together like this. Now, this is the furthermore shape that it is forming. Now, this is the shape. This is the tertiary structure. Now, this is the tertiary structure. This is the tertiary structure. Right? Wait a minute. This is the tertiary structure. Okay. This is the tertiary structure. This is the tertiary structure. This is the secondary structure. This is the primary structure. Okay? Seen it every time. You live in any forest or what? Very rarely now to I see snakes. Very rarely. When I was a kid, then I used to hear news from my parents that okay, there is some snake in the house, be careful. But now to I think humans have taken over everything, isn't it? So yes, structure of proteins. Now this is the quaternary structure. Quaternary structure is when further more complexity. Now you will further zoom out, further zoom it out. Then what you will observe that how different tertiary structures are combined together. For example, this is one tertiary structure. This is other tertiary structure combined this way. This is other tertiary structure combined this way. Other tertiary structure. How all of them are combined together, that is called the quaternary structure. Right? So that means the complexity is increasing. Basically, it is like zooming in. Outside from the earth, if you see the earth, it is like a globe. Right? It is like a oval shaped thing. Right? When you go inside, you will see grass. More inside. Right? Like if you zoom it, if you want to see moon from here and you zoom it in through the telescope, right? So earlier the moon will be like a white thing to you. Then when you zoom it in, it is actually not that pretty, right? Moon is not that pretty. Actually, moon has sand, right? Because of the reflection, we see that moon is white, but actually it is not white, right? So zoom it in and you will see that how the moon looks like. Similarly, this is a quaternary, tertiary, secondary, primary structure. It will look like this. Then zoom it into this particular chain. You will get the tertiary structure. That is this structure you will see. Zoom it in. Then you will get this kind of structure. That how it is it. Now again zoom it in. You will see how these bonds are getting formed. Understood? Understood, guys? Right? This is just zooming in. You're just zooming in things here. Right? This is quaternary. Focus on this thing. Zoom it here. Then you will have this thing. Right? Now they have shown you this in a very good manner. Right? So this is the quaternary structure where a lot of, for example, the snake is in the pipe and a lot of pipes are tangled with each other. Then that is the quaternary structure. Right? Where a lot of tertiary structures are tangled with each other. In the tertiary structure, here inside you have the alpha helix structure, right? Here inside you have the alpha helix structure, right? If you zoom it more in, this is how the alpha helix and beta pleated structure will look like, right? Then if you furthermore zoom it in, this is how the bonds are formed. This is how the peptide bonds are formed, right? Primary, secondary, tertiary, quaternary, right? Madhum, on 21st, 2025, I think here also something was about to happen. I think, I don't know, some astronaut, not astronaut, some asteroid, right? They were talking, I don't know which day, maybe last month. They were saying that the universe is going to die, we all will die, Earth will collapse, and some asteroid is going to hit it. And if it hit it too fast, but now the scientists have already calculated everything, and they told that okay, the asteroid will hit, but it will not be that. It will not hit the Earth. It will just pass very near to the Earth. But you will be able to see this. So tell me, how many of you were able to see this? Because I didn't see it only. I didn't try it only, right? I didn't try only. So yes, maybe 21st, maybe. Let us see. Because so many things are there in the news, but some of things will happen and some will not. Okay. Now, next is nucleic acid. So, nucleic acids are basically, we will talk about DNA and RNA here, right? What is DNA? What is RNA? Let us talk about this here. DNA means deoxynucleic acid. RNA means ribose nucleic acid. And this is deoxyribose nucleic acid. So you will form ribose here. One of the students in the starting, he was writing ribose. So ribose is useful here, right? So we will firstly draw the ribose sugar, right? Then we will see how they are formed, how DNA, RNA is formed, right? So basically one thing is that nucleotides join. Now first is the difference between nucleotides and nucleosides. In nucleotides, you will have three things. One is pentose sugar, other is phosphoric acid, third is nitrogen containing bases. Pentose sugar here is ribose. Here we are taking in DNA and RNA, the pentose sugar is ribose, right? Phosphoric acid unit, I will show you what is that, right? Now if you talk about nitrogen containing bases, this is adenine, uracil, thiamine, glycine, cytosine, right? These are the nitrogen containing bases, right? That you will see in DNA and RNA, right? Now, what is nucleoside? In a nucleoside, you can write it here. In a nucleoside, you will have only nitrogen bases and pentose sugar, right? Okay. You will have only those two things. That is the difference between nucleoside and nucleotide, right? Now, if you talk about the ribose sugar, this is how ribose sugar will look like, right? Now, in the ribose sugar, if we are saying this is beta D ribose, this is beta deoxyribose. Deoxy means we need to take out oxygen from there, right? So, from where we are taking out the oxygen? From this second position. Everything else is same. This ribose is used in RNA. This deoxyribose is used in DNA. Right? Because here on the second position, here you had OH, here you had HH. Here you would have HOH. Right? And this is used in the DNA, not used. This is there in the DNA. This is there in RNA. Right? So, if you talk about what are the other differences, other things. If you talk about other things here, this is nucleoside, this is nucleotide, as I told you the difference. In a nucleoside, you will have base and sugar. You will not have any phosphoric acid. But in nucleotide, you will have base, you will have sugar, and you will have phosphate. Phosphoric acid group also you will have. Right? So, this is just a term to define things. If they are talking about nucleotide, they are talking about three terms. If they are talking about nucleoside, there is no phosphoric acid unit they are talking about. Right? Only base and sugar we are talking about. Right? Okay. So, now let us see First thing though, we saw what is the sugar that we will use here. In DNA, we will use ribose. In RNA, in DNA, we will use deoxyribose. In RNA, we will use ribose sugar, right? If you talk about the phosphoric acid, second thing is phosphoric acid. So these are the different phosphates that we can use. Phosphoric acid, phosphomonoester, phosphodiester, phosphotriester. These are the different units that can be used. Next is nitrogen bases. Now the nitrogen bases are basically, they are the basic unit. I am talking about A, T, G, C, U. These are all the nitrogen bases. But the basic unit is purine and pyrimidine. This is how purine will look like. This is the unit of pyrimidine. In pyrimidine you have one nitrogen. In pyrimidine you have two nitrogens here. Purine is same as pyrimidine, but here you have one more penta ring also, right? Pentagon ring also, where you have two nitrogens. So this is purine, this is pyrimidine, right? Now let us see these are the basic structures, how different nitrogen bases are extracted from that. Now can you see that adenine, guanine, right? And yes, adenine, guanine. Okay, adenine and guanine, they are units of, not pyrimidine, these are the units of purine, right? This was purine, right? Okay, this was purine. So substituting different compounds there, we got adenine and guanine, right? Substituting which thing here? Substituting NH2 here, we got adenine, and substituting NH2 on this position and double bond O on this position, we got guanine. If you talk about rest of things, cytosine, uracil, thymine, this they can ask you what is the basic unit of adenine, that is purine. What is the basic unit of guanine? Purine. What is the basic unit of cytosine, uracil and thymine? These are, you can write CTA. These are pyrimidine units. And AG, wait a minute, CTA, no, CTU, that is pyrimidine unit, and A and G is purine unit. These are the purine units. This is the next question that they can ask you, that what are the basic unit, and out of this basic unit, this belongs to pyrimidine or this belongs to purine, right? The second question. Next is, in RNA and DNA, what combinations you have, right? So remember one trick here, that is at government college. So adenine is forming double bond with thymine, right? Okay. Should I write it on some next page? Chalo, I am writing here only. Adenine is forming double bond with thymine, and guanine is forming triple bond with the cytosine, right? Or this is the composition in DNA you will use, right? But in RNA, what will happen in DNA and RNA, the another difference is between thymine and uracil, right? In one you will have thymine, in the other you will have uracil, right? So let us see that. Now, they are talking about DNA and RNA. In DNA, you have adenine, you have guanine, you have cytosine, you have thymine. Where adenine is double bondedly connected with thymine, and guanine is triple, it is forming 3 bonds with the cytosine, right? If you talk about cysteine, right? Why I'm saying cytosine? Cysteine, right? So here, thymine is replaced by uracil. Instead of T, you will have U here. Rest of the things will be same. Right? So in DNA, this is the second question that they can ask you, that in DNA what you have, in RNA what you have. Right? In bio, so it is in detail. I think you have some principles also. Gopika, yes. Huh. At GC. Yeah, I think I told you. At GC. At Gopika ma'am class. This you can remember. At GC, at Gopika ma'am class. Right? So now let us see what is the other difference. First difference is between the sugar. DNA has deoxy, this has ribose, right? It has thymine, it has uracil, right? Okay. Now next thing is the structure of DNA, right? James Watson and Francis Crick give the double strand helix structure. Double strand means because of the hydrogen bonding between the bases. If you talk about this double bond I am showing, these are not exact double bonds. It is showing that E and T are forming 2 hydrogen bonds. G and C are forming 3 hydrogen bonds, right? This is not exactly double bond and triple bond. These are basically the hydrogen bonds. So exactly I'll show you this from the diagram itself, right? This is the diagram, right? Now can you see one thing here? This is thymine, this is adenine. These are forming 2 hydrogen bonds here. This is guanine, this is cysteine. These are forming 3 bonds here, 3 hydrogen bonds. So basically these nitrogen bases are forming bonds here, and because of those bonds there is double strand alpha helix structure, right? One is moving like this. One, if you talk about first one, it is going like this. It is going like this, right? It is going like this. Other is moving like this. Other is going like this, right? Other is going like this. So this is the double strand structure that you will get for DNA because of the hydrogen bonding of the nitrogen bases, right? Definitely they will not ask you to draw the structure, but they can ask you why there is double strand structure, alpha helix structure, because of the hydrogen bonding between the nitrogen bases, right? Okay, DNA is, now let us see the theory part here, right? 2 nucleic acid chains wound about each other, held together by hydrogen bonds between pair of bases. 2 strands are complementary to each other because the hydrogen bonds formed between specific pairs. It's specific pairs. A and T will form hydrogen bonds. G and C will form hydrogen bonds. Adenine forms hydrogen bond with thymine, whereas cytosine forms guanine. Wait a minute. This will be cytosine only. So bio, that's why I don't like bio that much, right? Because of these weird names, right? Now, let us see, our focus is on the structures only, right? So this is how in chemistry, they will not ask you the bio question. They will ask you the hydrogen bonding. They will ask you the peptide bonds. They will ask you the linkages, right? So focus on that in chemistry, right? So these are the hydrogen bonds that you will see here. Now, let us see the structure of RNA. In RNA, basically you have 3 structures: primary, secondary, tertiary, right? So if we talk about tertiary, secondary, it is having alpha helix and beta helix, right? The alpha helix is left-handed, beta helix is alpha helix is right-handed, beta helix is left-handed structure. From RNA also not that many questions are asked, but the questions are asked from these 3 kind of RNAs. So 3 kind of RNAs, one is messenger, other is ribosomal, right? Third is transfer RNA. These are the 3 RNAs that you have, right? Next is complementary. This so I already told you, adenine will form with thymine, guanine will form with cytosine, right? Then thymine always pair with adenine and vice versa. Cytosine always pair with guanine and vice versa. Now, these are the bonds that they are showing you, right? So, as I told you, thymine and or uracil pairs with adenine to form 2 hydrogen bonds. With uracil, it will be paired up in RNA. With thymine, it will be paired up in DNA, right? But G and C will always paired up in 3 bonds, whether it's DNA or it's RNA, right? Okay. Next is the structure of RNA and DNA, as you can see here, right? As you can see here, this is the structure of RNA. This is the structure of DNA, right? These are the bases that you can see here. Here they have written uracil, and here the base is thymine. That is the difference. Okay, that is the difference. The difference is in the sugar as well, right? What sugar they have used. Last is vitamins. So if you talk about the vitamins here, right? So this was about sugars, this and that. From sugars, DNA, RNA, remember the bases that you will use. Remember the linkages that you will have, where you have hydrogen bond, where you have disulfide bond, right? Okay, disulfide and hydrogen bond are there in proteins. Only hydrogen bonds are there in DNA, right? Peptide bond is there in amino acids when they will link together. Glycosidic linkage is in the carbohydrates when they will form disaccharides or polysaccharides, right? So these are the little things that they will ask you question from. Otherwise, this chapter is very simple. Now, these are the things that is there in bio, right? I think you know more than me, right? You are more good in this as compared to me, because I have not studied bio in that much detail, right? You have studied bio for 2 years, right? I have studied bio only till 10th, right? Now you, basically this whole that we are talking about, this was actually there in the lower classes as well. Vitamins, we will talk about the essential, non-essential vitamins. I think more will be there in bio, right? Do you have some chapters where you talk about vitamins and body? Or do you, because I have seen Gopika ma'am's classes, right? In zoology, you mainly focus on the bodies, animal body, human body. So I think for human body, this is the main thing that you should know, right? Okay. So vitamins, we will talk about in the chemistry perspective, that how they can ask you questions from vitamins. Basically, they can ask you questions from vitamin deficiency, and what will be the disease that can occur if you have a particular kind of deficiency, right? Like I have vitamin D, I have vitamin B12 deficiency. That is why I get ill very soon, right? So that is the things. That is why vitamins are so important, right? So you know what, when I got myself tested like 1 year back, I was like, my all vitamins will be like okay only. What's the need of testing it? But when I took the test, my vitamin D was around 34, and it should be around, I think 50 something, 50, 60 should be the minimum value. My vitamin B12 was on next level. It should be minimum, the deficiency range is 200 and I have 80. Now I have increased it to 250 or something. But I was like, oh my God, what I have done to myself, because I am a vegetarian, right? So I don't have B12 in my diet. So B12 will mostly in the diet of non-vegetarians, right? So vegetarians, if you are vegetarians, then you should also get yourself checked for vitamin B12 deficiency, because in my house, most of like my parents also have vitamin B12 deficiency, because like we are not eating vitamin B12 to that much extent, right? So then you need to have some multivitamins or some capsules for these things, right? So yes, that is a reality, right? Now even we have so much adulteration, that because of adulteration also there is lack of vitamins in the body. I think right now the biggest task for you also should be, with, I know you guys are very little for these things, but guys, I have seen this because I ignored it when I was of your age, right? Now I can see, you have seen my neck also, sometimes it's paining. All these are side effects of vitamin B12 deficiency, and it is the most common deficiency among like Indians, right? Most common deficiency. So I think you should also get yourself checked, because we are studying about vitamins. We should also know the practical application of this thing, where this is applied in our body, right? So we will now talk about all the things here, right? They have shown the capsules also, right? Some organic compounds are required in a small amount in our diet, but their deficiency causes specific diseases. These compounds are called vitamins, right? Now you see how important they are in our life. I have experienced it myself, right? Now vitamins, I think I am not a doctor, but after checking my reports again and again, now somewhat I have become a laboratory technician of this, not technician, laboratory person who is checking the reports. Now, vitamins are designated by alphabets A, B, C, D, right? Vitamin D, from sunlight we get B, A is very important for our eyes. Vitamin K is there in the green leaves, right? Etc. Some of them are further named as subgroups as B1, B2, B6, B12. Now, B12 is this what I was talking about, right? Now, let us talk about fat soluble. Now, they will ask you question from fat soluble and water soluble vitamins, right? The vitamins that are fat soluble, they will give you which of the following is a fat soluble vitamin. So just need to remember one thing. Fat soluble is ADEK. ADEK. Listen, AD. What is AD? AD means psycho, pagal, right? Say AD, right? So ADK, ADK, ADEK. That is your fat soluble vitamin. Right? Vitamins which are soluble in fat and oils but insoluble in water are kept in this group. They are stored in liver and adipose tissues. Right? So basically, they are stored in the liver. Right? This is required there. If you talk about water soluble, vitamins are also soluble but insoluble in fats and oils are kept in this group. They are readily excreted in urine because they are soluble in our body. Right? So, in our body, right, we take out water in the form of urine, right? From the urine, we also release some of the toxins, right, in our body. That is why drinking water, hydrating is important for you because you release toxins in your body, you detoxify your body. But also, some of the vitamins are also excreted out from our body through the urine, through this urine, right? That is why continuous supply of these vitamins is important for your body. Right? Okay, so they are readily excreted in urine and cannot be stored except for vitamins. Very, very important. Except for vitamin B12 in our body. Vitamin B12 is very important. It also leads to anxiety and all of that. Right? So vitamin B12, right, is stored in our body, though it is a water soluble complex. Right? It is water soluble, but still we can store it in our body. Right? Example are B and C. Okay, understood? The exception is important. All the other vitamins, vitamin B, right? If you talk about vitamin B1, B2, B3, B4, they are excreted out from the urine. But vitamin B12 is there in our body. We can store it in our body. And vitamin A, vitamin D, vitamin E, vitamin K, this also we can store it in our body. Right? Okay, this also we can store it in our body. And you must have, whenever we take the test, right, we focus on basically vitamin D, vitamin A, vitamin K, vitamin B12, right, that are actually stored in our body, right. Now, let us talk about that the deficiency will cause what kind of diseases. If you talk about vitamin A, right, now vitamin A will affect the eyes, right. So, when I was a kid, right, my mom used to pressurize me a lot to drink green leafy vegetables, to eat carrot. Carrot has a lot of vitamin A, but I used to ignore those things, and now that's why I have specs. Right? So don't do this, right? Drink a lot of carrot juice. Carrots have a lot of vitamin A. What else has vitamin A? Carrots so definitely has vitamin A. One more thing, there are different, I just forgot that what are the other things that have vitamin A. Carrot so definitely it has vitamin A, right? Okay, so where else you can get this? Carrots, butter, milk, fish liver oil, right? So also this was also told to me by some doctor that you should eat fish, then your eyes will get cured. But yeah, what to do, yaar? What to do? I was not able to. Right, that's why I am here, right? So that's why I'm here with these picks. So fish liver oil, the capsules are also there in the market, right? Carrots are very, very good source of vitamin A, right? Next is vitamin B1. So vitamin B1 is green leafy vegetables, cereals, milk, yeast, right? And if you have deficiency of vitamin B1, you will have beriberi, that is loss of appetite, retarded growth. Right, retarded growth, loss of appetite will be there, nutritionless, right? Then you will have vitamin B12, that is called riboflavin. Now this vitamin B2, right, this is in milk, egg white, liver and kidney. It is also present in liver and kidney, right? Now, if deficiency of this vitamin B2, it will cause digestive disorders, burning sensation of the skin, chillosis, that is fissuring of the corners of the mouth and lips. Some people now, I don't know if you have seen, one of my classmates, she had this thing that on the side of the lips, right, on the side of the, there is that much amount of dryness that it will cause redness over there, all over. I think when I was a kid also, I have also observed it myself, right? Some kids have like a very large amount of this all over their mouth. So basically it is not a disease, it is basically a deficiency, and if you fulfill that deficiency, that thing will be sorted, right? Okay. Now next is vitamin B6. Vitamin B6 is convulsions, right? And now here, where you will have vitamin B6, yeast, milk, green yolk, cereals, grams, again the same thing. Vitamin B12, fish, egg, curd, in all these cases, fish, meat, I told you, in non-vegetarian diet, you will have maximum B12, right? Egg, curd, right? So I don't know, vegans definitely, it's very easy to say that you go vegan, but I think vegans, you also need to, now we say that yes, Anushka Sharma, Virat Kohli, they are vegans because they have a proper dietitian, right, that is guiding them that these vitamins are not there in the diet of, in your milk, these vitamins are not in almond milk, these vitamins are not in soya milk, right? Then how to take these vitamins? By having capsules. So if you're thinking to go vegan, then you should also know that what are the things that you will miss, what are the vitamins that you will miss, right? You should be smart with it, and you need to know that how to consume those vitamins, right? Just by saying that I want to go vegan and by giving your body a stress, I think that is not a good thing, right? Rather than you, if you want to go vegan, then you should have a knowledge about these things, right? Then here you have RBC deficiency in the hemoglobin, right? In hemoglobin you have red blood cells, you will have a deficiency in that, and there will be pernicious anemia, that means blood will be less, right, in the body. Next is vitamin C, ascorbic acid. It is in citrus fruit, amla, green leafy vegetables, right? So this we all know, right? It will cause bleeding gums, your gums will be really weak, right? Then you will have vitamin D, exposure to sunlight, fish or egg yolk. Now here it will, if you don't have this, your bones will get weak, right? Bone deformities in children, right? Soft bones, joint pain in adults, right? These are the causes of vitamin D, right? Then vitamin E, vegetable oils like wheat, germ oil, sunflower oil. This finally for vegetarians we have something, right? That is why in India, most of the population, they don't have vitamin E deficiency. They have either vitamin D, vitamin B12. That is there found in the non-vegetarian diet, right? So here it is in the vegetarian diet, right? So vegetable oils, like, okay, we all use, like in India, so we use these oils, right? That is why there is, you will not see vitamin E deficiency anywhere, right? Rarely you will see. Increased fragility of RBCs and muscular weakness will be there. Then you have vitamin K, again in green leafy vegetables, increased blood clotting time, right? Blood clotting time means, for example, you have a scratch on your body, you have a wound on your body. So now what will happen? Immediately your blood will flow out of your body, but after some time there will be clot that will be there in the body. So for those people who have very thin blood, I told you this before also, aspirin, right? Aspirin is used for the thinning of the blood. So what will happen? The clotting time will decrease. So here also with the deficiency of this vitamin K, the blood clotting time will decrease, right? Okay. Next is, last one is hormones. Now hormones are basically in our body, right? Male hormones, female hormones, you have stress hormones, happy hormone, right? So many hormones are, our body is filled with hormones, right? So hormones are molecules that act as intercellular messengers, right? For example, I'm sad, I'm under stress, right? Your body will produce that hormone called cytocin. Cytocin? Wait a minute. Is this cytocin? I think it's not cytosine. The name was from C only. I forgot the name. Right? I forgot the name. It was something else. Arey yaar. I forgot the name. Yes. So the adrenaline is also a stress hormone. Right? I've totally forgot what is the name of that hormone. Right? Stress hormone. For example, we are talking about happy hormone. Oxytocin is a love hormone. Like, okay, I'm getting feeling for that person. Chemistry says that you're not getting feelings. Stop blaming your heart. Your mind is giving oxytocin. The mind is releasing oxytocin when you are attracted to someone, right? When you are happy, you are excited for your birthday or anything. Your body is producing dopamine, right? Your body is producing dopamine. That is why you're saying, I'm feeling very happy. I'm feeling very excited for this event. Why? Because body is producing that, right? So here, these are now when you don't have a proper diet, no, these hormones will also fluctuate. Right? That is why when we don't have a proper diet, right, then what you will feel sad, you will feel irritated. This is not what your heart is saying. This is what your brain is producing those hormones because you have not eaten well. You don't have a good daily routine. You are not, that is why I say that when you are preparing for NEET, it's not just that I'm studying like day and night. You also need to focus on your diet because when you focus on your diet, your mind will be relaxed. Right? Because your body will produce that dopamine hormone, right? Okay. Now, these are produced by endocrine glands in the body and are poured directly in the bloodstream, which transport this to the site of action, means to the brain. They help to maintain the balance of biological activity in the body, right? Now, let us see different hormones, right? Hormones also, the questions are directly asked, which hormones is present where, right? So, if you talk about insulin, insulin helps in keeping the blood glucose level within the narrow limit, right? That is why those people who have diabetes, there is basically the insulin hormone is fluctuated, right? Because of that, they have diabetes, right? If you talk about glycogen, it tends to increase the glucose level in the blood, right? Because if you have glycogen will break into glucose. So it is going to produce glucose, right? Next is epinephrine and norepinephrine. They mediate responses to external stimuli, for example, heat, right? Or you have any fear, you have height, anything is happening around you. You have just touched a very cold thing. You know that this is cold. You have touched something which is hot. You know that this is hot, right? How you know that? This is not because your skin is feeling. Yes, your skin is feeling that. Why your skin is feeling that? Because a hormone is released, a signal is sent to your brain that this thing is happening, right? Now, next is growth hormone, that is responsible for that why a girl looks like this, a boy looks like this, right? And sex hormones, right? Now, next is thyroxine. It is produced in the thyroid gland, right? Some people have the problem of thyroid. They can get really fat because of thyroid or really thin because of thyroid. So there is problem in this hormone. It is produced in the thyroid gland. It is iodinated derivative of iodinated. That means iodine is attached there of amino acid tyrosine, right? Abnormally low value of tyrosine leads to hypothyroidism, which is characterized by letharginess and obesity. Obesity means getting very healthy, very not healthy, very obese, very fat, right? So increased level of thyroxine causes hyperthyroxine. Now basically they are saying that low level will cause obesity and increased level, some people are really thin, they eat so much but they are really thin. Why? Because they have, again they should get themselves checked for thyroid, right? Okay, so you should have a proper balanced body, right? A balanced body, a obese body and a thin body, we can see that, right? So we should always get ourselves checked here, right? Now, steroid hormone, they are produced by the adrenal cortex and gonads, right? That is testes in males and ovaries in the female, right? Okay. Next is hormone released by the adrenal cortex play very important role in the function of the body. For example, glucocorticoid, corticoids, I don't know what these difficult names are, right? But they will not ask you this in chemistry. These difficult names they will not ask you. Control the carbohydrate metabolism, modulate inflammatory reactions and are involved in the reactions of stress. As I told you, adrenaline is responsible for the stress, right? With more stress, your digestive, some people, they binge eat when they are under stress. Some people, they don't eat only when they are in stress. Who are you? Like, do you eat a lot of things when you're in stress, or you don't eat nothing when you are under stress? I eat a lot when I am under stress. Like, I eat random things. Like, I need really, really good food when I'm in stress. I need fried, I need pizza, I need burger, I need mixtures, I need biscuits, namkeens, I can't eat a good healthy food when I'm under stress. Right? So basically that thing is playing. It's not my heart is saying, my heart is wanting, my heart is craving for this thing. No, my mind is telling me that you need this thing. Right? That is how you can, this is basically our mind is not under our control. Right? The adrenal cortex does not function properly, then one of the results may be Addison's disease, characterized by hypoglycemia, weakness and increased susceptibility of the stress. Basically anxiety. Right? Adrenaline is a very, that is why you must have seen this eating nothing when you are in stress. I to eat a lot when I am in stress. Right? When I'm stressed, like if for example, I have exam that day, I won't be able to eat that day, but day before that, I'll eat like crazy. I'll eat everything. I need all the spicy food. Everything spicy I need. Right? Now, here, you must have heard this term, that adrenaline rush, right? This is a Gen Z term that we use. I have adrenaline rush. I feel very happy. I want to jump out of that. I feel very happy when there is adrenaline rush. Basically, it's not adrenaline rush, right? It's not good for you, right? It's not good for you. Basically, what will happen when you are in a situation that is causing fear and stress in your mind, this is adrenaline rush in your body. We say this in a positive sense, that there is a very good thing, it gives me adrenaline rush. I want to skydiving. Array, because of skydiving, I'm not saying don't do that, right? Do that, okay, enjoy your life, but don't think that adrenaline rush is something that your body wants. Your body doesn't want adrenaline, right? It is a stress hormone. Okay, the disease is fatal unless it is treated by glucocorticoids and mineral corticoids. Basically, they are talking about the anxiety, the depression, the stress that some people, I know some people, they are in depression in some season. Like some people I know, like a common friend, they are in depression, that person is in depression and in anxiety when there is winters. In summers, no, in winters. So this is how the body and the hormones play with the mind, right? Okay, that is why this yoga, gym, working out is important. That is why cycling is important. That is why making your body feel good is important, so that you can have control over this mind, right? Control your mind. If your mind controls you, you're going to get finished. Right? Now, next is testosterone. Testosterone, we all know that it is a male hormone produced in the testes. It is major sex hormone produced in the males. It is responsible for development of secondary male characteristics, deep voice, facial hair, genetical, physical constitution. Right? If you talk about estradiol, now this is a hormone produced in female. It is a main hormone. It is responsible for development of secondary female characteristics, that is control of menstrual cycle. Right? Now next is progesterone. It is responsible for preparing the uterus for implantation of the fertilized egg. Right? So these are the different sex hormones that define male and female. Right? Okay. Now next is, we have finished the chapter. Let us do some previous year questions so that you can get an idea what kind of questions will be there. Right? So NEET to 2020, the question is sucrose on hydrolysis. It will give you alpha D glucose and beta D fructose. Beta D fructose. So C is going to be the correct answer. Right? Alpha D glucose and beta D fructose. Next is the difference between amylose and amylopectin. I told you both have Both have same thing. It's just the linkages are different. Both have alpha glucose only. It's just that in amylopectin, you have 1,4 alpha linkage and 1,6 alpha linkage. In amylose, you have 1,4. No, amylose, you have only 1,4. In amylopectin, 1,4 alpha, 6 beta. No. Amylose is made up of glucose and lactose. No. Both are made up of glucose only. In amylose, you have 1,4 linkage. In amylopectin, you have 1,4 and 1,6, both the linkages. So answer A is the correct answer. That is NEET 2018. Latest question, right? Next is, which one have non-reducing sugar? Non-reducing sugar. Now, these are the disaccharides. These are the disaccharides, right? I told you disaccharides are usually reducing only, right? But one exception we have, that is sucrose. So, sucrose is that non-reducing sugar. This is asked in 2016. See, direct question, one second questions they are asking from this one, right? Next is, which of the following is a basic amino acid? As I told you, from basic acidic amino acid, they can ask you question. NEET 2020 question it is, right? NEET 2020. Anybody in the chat box? Serine, alanine, tyrosine or lysine? Very simple it is. Everybody, what is the correct answer? What is the correct answer? D, lysine. Told you na that this is a basic amino acid. This is a basic amino acid, right? This is a basic amino acid, right? Because it has more NH2. 2 NH2 group, it has 1 COH group. 2 NH2 means more NH2, more basic units. That means it is basic in nature. Oi hoy. Non-essential amino acid among the following. Non-essential amino acid, that is not, that is basically produced in our body. It is not required from outside. The non-essential amino acid is alanine. That is a non-essential amino acid. Next is NEET 2019. Which structure of protein remains intact during denaturation? Denaturation means when your different structures, if I tell you what is denaturation, then you will got to know the answer. Now tell me what is the correct answer. Basically, quaternary to tertiary, tertiary to secondary, the structures are decreasing, the complexity is decreasing, the breaking of the bonds here. So tell me which will stay intact here. Which will stay intact here? Which will stay intact? Both secondary and tertiary, primary structure only, secondary structure only, or tertiary? Which will stay intact? Primary structure will not change. Quaternary structure will break, tertiary will break, secondary will break. Right? Very good. Primary structure will stay intact even after denaturation of the protein. Right? Next is, which of the following compounds can form zwitter ion? Right? Which form amino acids can form zwitter ion? So this cannot, this cannot, this cannot. This so we have done yesterday only. What is acetanilide? What is aniline? What is benzoic acid? Right? We have already done that. Right? There is no acidic or basic unit in that compound itself. But in glycine, which is an amino acid, you have that acid and basic unit. So answer is D for dosa, ma'am. D is the correct answer. 2007 is, which of the following vitamins is water soluble? Water soluble. A, D, E, K and B12. These are fat soluble. Rest A, D, E. These are fat soluble. This is water soluble. Right? Except for vitamin B12 that can be stored in the body. Right? Except for vitamin B12 that can be stored in the body. So answer is again D is the correct answer. Very good. Next is, which of the following hormones contain iodine? We have just seen that. Which of the following hormone contains iodine? Which will contain D for Diksha sir? Yes, B for Baswa ma'am. Which of the following will contain iodine? Let us see how many of you can answer this. Which of the following hormones contain iodine in it? That is your thyroid hormone, right? Okay, so that is thyroxine, right? That is present in the thyroid gland, right? Thyroxine will contain the iodine, right? Okay, this is the thyroxine hormone. You don't need to learn the structure here. Okay, you don't need to learn the structure, right? Next is glycogen is a branched chain polymer of alpha glucose units, which is formed by C1, C4. Whereas branching occurs by this. Structure of glycogen is similar to which thing? It is similar to which structure? Amylose will have only C1 and C4. Amylopectin has C1, C4 and C1, C6 of alpha D glucose. But here the glycogen will have more complexity. Yes, very good. It is similar to B. That is amylopectin. B is the correct answer. NEET, which this is the question of NEET or what? No. I think it is not mentioned here, but it is a previous year question only. Right? Next is, which of the following polymer is stored in the liver of the animals? In the liver of the animals. Animals. Cellulose is stored in plants, right? Which is stored in animals? This line I told you when we were doing the chapter. In the theory part, we have discussed this. Very good. This is stored in the glycogen, right? This glycogen is stored in the body. Animal, we are also animal, right? It is stored in our body as well, right? And it will break into glucose, right? Next is, which of the following pair will represent anomers? So this is how they will give you question. That is why I was telling you, focus on the linkages, focus on glucose fructose structure, and then focus on the linkages. They will not ask you to draw the structure, right? Now, which of the following pair represent anomers? Anomers, right? First should be opposite. Rest of them should be same. This is representing anomer. First should be opposite. Rest of them is, this is also opposite. This is also opposite. Right? This is also opposite. Right? So these are not anomers. These are not anomers. Only C1 should be opposite. Right? Only one position should be opposite. Here, as you can see, this should be opposite. But this is same, this is same, this is same. Right? Yes. These are representing epimers. Why these are representing epimers? Right? These are not anomers, these are epimers of each other. Right? Because these are open chain. Anomers should have a cyclic structure. This has a cyclic structure. So these are anomers. These are anomers. Right? What about this one? H, this is opposite. This is opposite. Two are opposite, so definitely it can also not be anomer. So answer is C is, yes, A is epimer, C is anomer. Right? A is epimer, C is anomer. Right? Okay? A is epimer, C is anomer. This to confusion was sorted, but students make mistakes here. Open chain is epimer, closed is anomers. Right? Next is, I think that's it. Okay, guys? Everybody in the chat box? Everybody in the chat box? So now, students, let us see. Wait a minute. Let us see what are the offers going on here. So as you can see here, right? So I'll show you 2-3 things here. Organic chemistry we have completed. So this is the QR. This is basically QR booklet of organic chemistry, right? Here you will get all the naming reaction, the full-fledged organic chemistry in this little book, right? And this will be written in a very, very beautiful manner, in a short manner, as you can see here. So written in a very, very beautiful manner. All the naming reactions, the tricks, everything. Like we have everything, optical isomers, the naming reaction, dextro, levorotatory, everything, S configuration, R configuration, everything is mentioned here for your quick revisions, right? And in a very beautiful manner it is mentioned here, right? This thing, and you will get these flashcards here. As you can see, these flashcards. So if we talk about anything, if we talk about chemical kinetics, this is how you will see, right? All the formulas will be written here. Then you will have the graphs here. All the graphs you will see here, right? Everything will be in a very crisp manner, right? So I would highly advise you, wait a minute. Yes, I will highly advise you, all of you, to purchase these flashcards and the QR booklet that will be available to you. Wait a minute. Firstly, tell me how many of you have already purchased it. Because students, this is important. That is why I am again and again insisting that. Right? Wait a minute. Oops. I think the flashcards are not now available. That's why I was telling you. I need to check with the team. I need to check it with the team. Okay? I need to check it with the team if the flashcards are still available or not. And if I make it available for you guys, then please purchase it now. Right? Because the availability is going to go. Right? Then you will feel that, ma'am, why I lost these kind of things. Right? I was telling you yesterday itself the page was opening. Right? So I need to ask the team whether they are available or not, or there is some glitch over here. But I'll tell you that in the Telegram channel. Purchase it right now. Purchase it today itself. Right? Okay? Because after that you will feel really, really sad about it. Now next thing is, the other thing that I want you guys to purchase is this Tejas books. Right? Because in these Tejas books, this is just for chemistry. Right? We have for bio and physics as well. That will be available to you on this link. Wait a minute. Or this link. Where is this link? Tejas books. This is the link. Right? This is the link for Tejas book. Thank God this is available to you. Right? So now this is the link, because students, you know what? A lot of students are already ordering that. Right? That is why maybe it has gone out of stock. Now again it will go in the stock. But once it is going in the stock, I want you guys to purchase it in that first day only. Right? Okay. So now here it is for 1600. Right? You will get this. The price is going to get increased anytime. Anytime this will get increased. Here you will get chemistry, bio and physics, all the 3 books. Right? You will get detailed explanation. You will get a lot of questions. You will get a summary based things. In flashcards, you have flashes. Flashcard is basically in a flash you can revise the chapter. But here you will have short notes in the Tejas books. Right? You will have short notes in the Tejas books. Now, here you can just go to this option and buy now. You can purchase these Tejas books. These are the 2 things that you must have. Right? Then next thing is, let me see. Viku, I want individual subject. Individual subject you need, no? So individual subject is also available here. Wait a minute. Wait a minute. Individual subject is also available here. Let me see where it is available. PCB combo, this is. Individual was also available before. Right now I'll have to see. You can just go through that. Right? And I'll ask the team to add it here only. If you want to purchase the individual book, like for chemistry or this, that was also available. I think that was for about 600 rupees. Right? That was for 600 rupees. Right? Okay. That was for 600 rupees. Individual books were available. The combo is available for 1600. I would advise you to purchase it for the combo. Right? Then you have, if you want to purchase, these are the 2 things that you have must have. Then you have third thing is NYTS. Right? NYTS. This is year-long test series. And this year-long test series is available in the combo with the DNA batch plus test series plus Tattva book combo. And these all things are available to you on, all these things are available at 5499. Right? Right now the price is 5499. After 2 days, what will be the price? I don't know. Right? Okay. So DNA batch plus you have year-long test series, 25 tests will be available to you. You can attend those tests online. You will get a report card. You will get the weaknesses, points, everything you will get there. Right? How many questions you have solved, where you got wrong, and also you will get the video solutions of those tests. Right? So everything you will get there. Now, these were the 3 things that I would really advise you to purchase. Right? Okay, guys. Okay, guys. How many of you have already have purchased flashcards and Tejas books and NYTS? How many of you? Tanuja, Sigma, Mardei, Disha, Sneha. Yes, how many of you have already purchased the flashcards? How many of you have already purchased the Tejas books or Tattva books? Right? How many of you have already purchased the uh, a year-long test series? Right? Wilson has purchased it. Which thing you have purchased? Going to purchase the Tejas, ma'am. Okay. Tejas, you can purchase. Tanuja, that is combo I would advise you to purchase. Okay. Combo is something. I got it. It's so amazing. What you got? Tejas or flashcards? What you got? Tejas you got or flashcards? At your home only, na? Flashcards and Tejas. Is it amazing? What's your review? Wilson, I want you to write down your review in the comment section. Right? And also send me one photo of your purchase. Like send me one photo of your favorite flashcards, right? Favorite chapter or favorite flashcards from these. Okay, I would love to know that because this is one of my favorite things, right? Okay, so other students also, because Wilson has already purchased it. So good, I need flashcards for chemistry alone, ma'am. For chemistry alone, I doubt it. It's not available. It is only available in the combo, right? Because already the price is very low, right? The price is already available. Is it available? I think for chemistry individually, it is not available. I'll ask the team if they can make it available individually. If you want Tejas also individually, if you want flashcards also individually, then I have to ask the team. But I don't know why you're not purchasing it for physics and bio. Bio also is like direct. I'll ask Gopika ma'am and Shreya sir to show you that, right? They can show you the flashcards of that also. This is also very interesting, right? Okay, so I would advise you to purchase a combo of that. Because once you will purchase chemistry, then you will like it. Then you'll say, ma'am, I also want to purchase physics. You'll say, ma'am, I also want to purchase bio. It will cost you more. A combo will cost you less. It's like a McD meal, no? When you purchase it together, it costs you less. The same thing. Right? Okay. Okay then guys, bye-bye. Take care. See you all in the next class. And Wilson, yes, I'm waiting for your comment in the comment section. How you like the flashcards. And those students, we have already completed full syllabus. We are just left with one chapter. I want you guys to write it down in the comment section whether you want me to take up the P block in one shot or you want me to take up the P block individually, like group number 13, 14, then 15, 16, then 17, 18. 3 lectures I will make. Or if you want me to take up the P block like in one shot. Okay? Yes. And also if you want me to take up from NCERT or from my notes. I would advise NCERT is better for inorganic chemistry. Yes? Okay, then bye-bye. Take care. See you all in the next class. Till then, take care of yourself and keep smiling. Keep spreading the